Okay, Marcel and Valerio, can I check if you have... What options do you see in terms of preloaded slides or screen sharing at the moment? Is it still saying... I don't have many options and I can't see the preloaded slides, so I don't know what you can see, if it's different.
I have two buttons, share preloaded slides and share screen. And if I click
Yep.
share preloaded slides, it says all slots for the requested media are already taken.
Right.
And same thing.
Hello guys, this is Alessandro from Miteco. Can you hear me?
Hello.
Yes,
Hello. So you wanna test your slides from remote?
As in, like, sharing their screen or using the pre-shared?
Yeah, it's up to you. What would you prefer? I'm just leaving the floor to you and just test what you want to share. Okay?
Yep. Marcel, Valerio, would you prefer to share your slides yourself? Then you've got total control.
it doesn't matter too much to me.
Yeah.
All right. So,
If you
yeah.
just
Oh, I
have
see.
slides and you don't want to show like videos or images, then preload the slides. It's a better choice.
I see. Okay, I see. So I should be able to hit this.
That works.
And then I see. I can advance like this. Cool. I see. It's just because the video was sharing in the middle before, and Alessandro turned that off. I see. Thanks.
Yeah. No.
Okay. Yeah.
Yeah.
Can I try it?
Yeah.
Yeah.
All right.
Okay.
Looking good.
Okay.
Easy peasy. Thank you, Alessandro.
Thank you.
You're welcome. I'm taking the floor again.
All right.
Talk to you later.
So that's probably the kicker, I guess. Okay. But now I need to know the...
I hear room audio. It's like, in a weird way, it's like the room is the side meeting.
Yeah. Is this going to be the room? Oh, yeah, there we go. Part of it, anyway.
It's the front of the room. Good morning, good morning. I saw one of my co-chairs. But the room is silent. I know there are people there. We just can't see them.
Hello, hello. There we go.
Hello, hello.
Perfect. So this is not touch, so we need the clicker. Oh, thank you. Perfect. So we were planning to actually wait 1 minute, but since we are already above that minute, we can just start. Well, welcome. Good morning. Welcome to the Math Working Group. My name is Massimo Candela, and together with Nina and Steven. Nina, she's here physically, and Steven is connected remotely. We are the chair of the Math Working Group. Math stands for Measurement Analysis and Tools. And this is what we will talk today. We have a really packed agenda of what I believe are very interesting topics. And well, I think we can start immediately. So this time we did slightly, I would say, new thing. Let's see how it goes. So we introduced a subtract, and the subtract is about vantage point selection. The subtract will take the first 30 minutes, and vantage point selection is an extremely interesting and important topic both for active and passive measurements. So if you ever have, I mean, whenever you do measurement at some point, you have, especially when you want to make it scale, you have this problem of vantage point selection. Imagine that you want to, for example, find the location of an IP. You want to use a latency measurement. You think, oh, let's use RIPE-Atlas. But what are you going to do? We use 11,000 probes for each IP. And so what vantage points can you select to make that are the best for your measurement? This is just an example. But the presenters will talk with more details about this. And after this initial vantage point selection track, we will resume with presentation about tools and analysis after. Also, another thing that we did is that we know that the audience of math is a healthy mix of operators and researchers, researchers both from academic and not. So we actually try to strongly prefer presentation that they have that they are appealing for both, and that also we ask the presenter to make an extra effort in expressing what are the guidelines and the takeaways that they will have an impact on the internet, the current internet, and the future of the internet. Of course, we also look for your feedback, and I brought here our mailing list. I also would like to thank Aoife from the stenography, and also Guy Meyer for the scribing. They're both here, so don't speak too fast to make their life a bit easier. And thanks for their hard work. And we can start with the agenda. So we will have the first speaker. I will just start with the first. I will anyway introduce all of them. So the first two are about the vantage point selection, and we can immediately start with the first presenter. The first presenter is Thomas Alterbeck. He obtained his PhD from ETH Zurich in 2021. He's now a postdoctoral researcher at the University of Strasbourg, where he works with Professor Christel Pelzer, which she's a super contributor of this community, and I say her hi. I hope to see her back soon. On how to improve internet routing performance, security, and operability. So Thomas will present MVP measuring internet routing from the most valuable points. And Thomas, the stage is yours.
Okay, thank you for the introduction, and good morning, everyone. Today, I would like to start this presentation with this figure. This is the median number of BGP routes that are collected every hour by the RIPE-RIS infrastructure. And you can see that last year, this number reached 45 million. And you can see that it actually exponentially increased, which means that during the coming years, we can expect even more routes that are being collected. So we see this exponential increase for two reasons. First, because there are more and more vantage points, but also because there are more and more prefixes that are advertised in the internet. And for every new prefix that is advertised, there will be new BGP routes that are collected. So of course, one of the common solutions that probably we all do is we just select a few vantage points and we take the routes that they collect. Okay, so if you take this simple example where there are a few ISCs, they are connected to each other, and then there are a few vantage points as well. Well, what we could do is we can just take the data from a couple of vantage points here. So then we would have less data to process, but in the meantime, we might also lose some information, right? So selecting the right set of vantage points matters, but it's challenging. It's challenging because there are two conflicting phenomena. First, we observed a lot of redundancy between the routes that are collected. Okay, and this effect is actually amplified by the fact that the vantage points, they are very often positioned in the very core of the internet. Okay, so this, for instance, is a figure where on the x-axis you have the 70,000 something ISCs, and on the y-axis you have a CDF of the vantage points. And you can see that around 5,000 ISCs, so a rather small fraction of them, hosts 62% of the vantage points. Okay, so this is a reason why we have so many redundancy between the routes that we collect. But we also see with those routes like a sparse BGP event visibility. So what does it mean? Well, we took this table from Manners that they published in 2021, and which shows that 65% of the BGP hijack that were detected in 2021 were detected only by 20 or less vantage points. Okay, so this is only a very tiny fraction of the vantage points. So here, basically, there is a trade-off. On the one hand, we want to remove as many vantage points as we could in order to avoid redundancy, sorry. But on the other end, we want to keep as many vantage points as possible to make sure that we will observe the events we might be interested in. Okay. So today, I would like to introduce you MVP. MVP is a system that selects a set of vantage points which strikes a good balance between avoiding collecting too many redundant routes, but still being able to collect the routes that will allow you to detect the events you might be interested in. So in other words, the goal of MVP is to select a set of vantage points that maximizes the utility of the data and minimizes its volume. And we do this in 3 steps. First, MVP quantifies the observation of the vantage point for past events. Then it measures the similarity between the vantage points for every event. And finally, it selects a set of dissimilar vantage points. So let's first see how it quantifies the observation of the vantage points for past BGP events. So MVP actually computes the change induced by the appearance of new AES links in the topology using topological features. So what does it mean? Well, let's consider the same AES topology that I showed before. And imagine now that AES 3 and 4, they start to pair. So there will be a new AES link between those two AESs. So what MVP does here is that it computes feature values, topological features, right, before and after the change to compute the change induced by these new AES links. And then it do this for all the vantage points, okay, because there are many vantage points, and all the vantage points, they see a different partial view, okay? So we do this computation for all the vantage points using, again, topological features. We use a total of 20 different topological features, which can be divided in 3 categories. Here, I am not going into the details, but basically, we try to use many different topological features to make sure that MVP does not overfit for one particular use case, but remains very generic. So it will work regardless of what is your objective. Then the second step is about measuring the similarity between the vantage points, and this for every event. So how does MVP do it? Well, here I'm showing a little example on the right. So instead of taking all the topological features, I'm just taking 2 of them. So we have only 2 dimensions here: number of triangles and average neighborhood degrees. Those are the two features that I take. And the dots here are the vantage points. Again, we would have many more vantage points in practice. Here, there are just a few for simplicity. So we just run k-means, a clustering algorithm, and then we can cluster the vantage points, and 2 vantage points in the same cluster basically observe an event the same way. Okay. Finally, MVP selects a set of dissimilar vantage points. Okay, so how do we do it? Well, we take many past events, 750 in total, and we make sure that every event that we take is visible by at least 10 vantage points, and we also make sure to take events that are scattered everywhere on the internet. Then MVP runs the clustering that I just showed you before on all those events and independently from each other. MVP then uses a pairwise similarity score that estimates the similarity of a pair of vantage points across all the events now. Okay, so basically this score is a value between 0 and 1. 0 means that the 2 vantage points, they are dissimilar, whereas 1 means they are very similar. Okay, so here I'm just showing an example again. So there are 3 events only. Again, in practice, we have 750, but for simplicity, I only show 3 events. There is the clustering for each of them. And imagine now that there are 2 vantage points, VP1, VP2, and you can see that they are never in the same cluster here. So their similarity score is equal to 0. They are very dissimilar. We do the same for VP3, VP4, but this time you can see that for event 1 and 3, they are in the same cluster. So their similarity score is equal to 0.67, so they are rather similar in this case. Then MVP uses this similarity score to greedily build a set of dissimilar vantage points. So how does it work? Well, we first select the most similar vantage points, and then we select the vantage point that is the most dissimilar with the ones that have been selected already. Okay, and we repeat this process in a greedy manner in order to obtain our set of vantage points. Let's now evaluate Swift, MVP, sorry. So we have here, again, we focus on the trade-off between volume and utility. And here, we actually evaluate MVP on 3 use cases. First, the number of discovered AES links, then the proportion of detected hijacks and new AES links, and finally, the proportion of detected transient paths. And we compare MVP against 3 baselines. First, a random strategy. This is probably like what most of us are doing now. We just select vantage points randomly. Okay, then we also compare MVP to distance-based. Distance-based is a selection strategy where we try to take vantage points that are the most distant based on the AS topology. And finally, we compare it to max AS links, which is another baseline where we try to select the vantage point that observe the highest number of AS links. Okay. Well, it turns out that MVP always exhibits the best trade-off between volume and utility of the data. So let's focus, for instance, on this use case. Again, as I said, you are interested in the trade-off between the volume of the data here on the x-axis and the number of discovered links on the y-axis. And this is the result. So as I mentioned before, MVP outperforms all the other baselines. It even outperforms max AS links, because max AS links only try to observe the highest number of links, but doesn't consider the volume of the data at all. Whereas our solution try to optimize this trade-off between utility and volume of the data. So here, for instance, if you want to collect and see 300,000 AS links, you could get those AS links with 58% less data if you use MVP compared to if you would use a random selection strategy, for instance. Okay, for the two other use cases, I invite you to look at our poster that we presented this week at IMC. Now I just would like to conclude this presentation with this QR code. So we have an alpha version of MVP that is running in one of our servers. So if you want to try it out and get a list of vantage points that you could use for your experiment, you can scan this QR code and try to use those vantage points. So thank you very much, and I'm happy to take your questions.
Do we have? Okay, I woke up. Do we have questions? Well, do we have questions online? No. Then I have a question for you. So in particular, I wonder for real-time queries, how long does it take for your solution to actually to return a set of vantage points that are useful for the query?
Yeah. So the idea is, you know, all those clustering and this technique that I described, we can compute it every day in one of our server, and then you as a user, you just request the results, so it will be very fast then, because you don't have to do any computation in real time. You just request the set of vantage points that have been selected for this particular day. So for instance, then you could use this tool probably for most of the experiments, including also tools such as BGP Alerter, which probably use some of the BGP data, and that could also maybe improve the performance of those kind of systems. Yeah.
Thank you very much.
You're welcome.
Thank you very much. Oh, okay, we have a question.
Leandro Bertoldo, University of Twente. When you analyze, for example, the neighbors of each one of these vantage points, you just consider in the IS path, or you are considering the feed of the information of each one of them?
What do you mean by the neighbor of the vantage point?
For example, I saw that you have, like, for example, RRC15.
Yes. Ah, you mean, okay, yes.
Yeah,
so
then you have all the other ISs that are sending feed to him. You are considering the feed as the information, or do you?
No. So here we consider a vantage point, not a collector. So if you look at the set of vantage points that you have, you should have RRC something and an IP address, or maybe a nice number, which is the vantage, which is the router in this IS, which is exporting the routes to the collector, right? So this is not per collector, it's per vantage point.
Okay.
Right, because otherwise it's fact you get all the data from a collector, but in the collector there are a lot of vantage points. So yeah, no, we really work at the granularity of a vantage points. So a BGP router that exports its routes, not at the granularity of a collector.
Okay, thank you.
But that's a good point.
Perfect. Thank you again.
Thank you.
Thank you very much. So we can go now with the next presentation. The next presentation, still on the vantage point selection, is from Malte. Malte is a researcher at the Internet Initiative Japan. His topic of interest include internet measurement with a focus on understanding internet topology and dependencies. He often works with large set of RIPE Atlas probe, which sparked his interest in unbiasing measurement. So Malte will present METIS Better Atlas Vantage Point Selection for everyone, and the stage is yours.
Yeah, hello there. Thanks for having me. Yeah, so I will continue the topic of vantage point selections, but now from our nice RIPE Atlas. Yeah, the introduction I can skip because we already had it. So I do a lot of work with RIPE Atlas. And the quick TLDR and also a disclaimer. I just noticed that my poor LibreOffice presentations are not supported. So you will get the whole slides without animations. So what I will present is a tool that provides an alternative to the existing Atlas point selection. So when you create a new measurement, you get this nice interface that asks you how many probes do you want, and then you can either select from ASs or from an area. And this is basically a selection of methods that you can use as an alternative to the existing ones. Because the distribution of RIPE Atlas probes currently, and yeah, who knows how long in the future, makes the default or the worldwide selection sadly not that worldwide, or at least yeah, it has some bias, let's say, or focus. And so this is the probe distribution map that you maybe have seen before, and we have our large blobs in Europe and the US. And if we put that into a plot, this distribution, sorry, this data is also from February, so these numbers are a bit outdated. Now we think we have over 12,000 probes already, so yay, more growth. And if you plot this by country, so this plot has 1 point per country, and it says how many or the percentage of the probes within each country. And so the higher up you go, the more countries are in your probe set, and the more to the right you go, the more probes are contained in a single country. And so, for example, you have like 150-ish countries which have less than 1% of the probes. And so if you would have a perfect vertical line, then your probes would be perfectly evenly distributed between your countries. And then if we look at the tail distribution, so we have the country with the most probes is Germany, actually, followed by the US. So yeah, if you look at the geographical size of the countries, very good representation. And if you then go into the AS level, so RIPE at that time covered 3,600 ASs, but then you have like 306 or 370 probes almost in the Deutsche Telekom AG, so one German AS, and that makes up like 3% of all probes and also 23% of all German probes, for example. And I think we mentioned that also earlier, so we as users cannot just simply run measurements with all 12,000 probes, so we have to do a selection. And so yeah, this is the aforementioned interface you have. So you select, for example, 1,000 probes and say, yeah, give me please a worldwide selection. But the result is then, so on the right, what does it give us in this example? So the number of countries represented by the probe set is then reduced. So this is now, I think, 93. But we still have the same top 3, only in a different order. And now, relatively, so percentage-wise, even more probes are now in the US. So yeah, we wanted a worldwide selection, and now, yeah, we still have the same thing, but with only less countries. And so if I'm a researcher and I want to do measurements, the selection is also, of course, randomized. So every time you do that, you might get a slightly different set, but we tried it several times and the trend always looks the same. And if I'm a network operator, for example, who wants to know how is my AS reached from the world, yeah, it might be, this would be maybe more like how is my network reached from the US or Germany or France. And yeah, so again, this again the whole slide at once. So what we now try to do is we do very simple things. So we don't do any claims of like optimality or this is the best thing, but we just want to do a better thing. So this is how our system looks like, or how Atlas looks like on an abstract level. We have our probes, and these probes are in one or multiple ASs. Or no, each probe is in one AS, but you might have ASs with multiple probes, as we saw. And we now put these ASs into some relation to each other, so with a distance metric between each AS. And the idea is simple, so we want to avoid probes that are close together, whatever close means depending on the distance metric, because the measurement results you will get from them, we expect them to be very similar. So you don't get any new information, so why should we choose two probes that are directly next to each other? And so we do that in two steps. So the first step is a very broad simplification. We simply choose one probe per AS by design. So that might seem a bit harsh, but for us that was a good way of cutting down these large clusters of probes that are at least in the same AS. And then in the second step, this is a bit more intricate. We then want to reduce probe clusters or probes that are close together but in separate ASs. And how we would do that in the long version of the talk, I would now give a 5 minutes explanation of that, but we don't have too much time, so I give you the short version. So we use the RIPE Atlas topology measurements to build a distance matrix between all ASs that contain probes. And then based on this matrix, so for multiple distance matrices, distance matrices. And based on that, we then select a subset of probes that are the farthest away from each other, or put differently, we iteratively remove in one AS at a time, the AS that is the closest to all the other probes until our probe set is small enough for whatever size we choose. And if we do that, so here we have it for two distance matrices. So we use the AS path lengths between the probe ASs and also the round trip time. And so this is the same plot as before. So ref is our whole Atlas distribution and WW is the worldwide distribution. And so if your line is higher up, you have a more geographic diversity in terms of countries, and the more to the left, the more even your probe distribution is. And so if we look at the green line, that is for round trip time. So here we get more countries. So now we have 148 countries, but still a lot of the probes are in this case located in Russia. So 11% of our 1,000 probes, so this is for the selection of 1,000 probes, is in Russia, which I guess makes sense. So if you use round trip time, that at least most of the time has some relation to physical distance. So here, this method actually then shows like 100 probes from Russia, I guess, because the round trip time connection between them is relatively large. And if you then, for example, choose AS path lengths, which does not really look at your physical geographical distance, but more on your internet topology space, you get a bit less countries, but at least the probes are spread out a bit more, because then probably within a single country you have so many ASs that they are still like on a topology view far away from each other. And so I plot this here as with countries and percentages per country, but of course the selection algorithm has no idea of the country, so it only knows we have ASs and we have distances, and that they then spread out over multiple countries or not is just a side effect of how the internet topology maps to your countries. And we're also not arguing that having one probe per country would be the best or not. So it's basically just, you can pick your own distance metric that suits your use case, because if you won't have one probe per country, you can simply select it like that. You don't need this. And so I guess the more important point is, so you can also use this, hopefully, please do. And also let me know if you have any ideas for other distance metrics. So at the moment we have AS path length and round trip time. We also have IP hops, so from chase route, the number of hops, but we found that, not too useful at least. And so we update this data weekly, and you can just get the probe sets via a web form, and this we also provide you with a API specification that you can put into the RIPE Atlas interface, because sadly, at the moment, we cannot provide the measurement interface with a list of ASs. So you have to do like a very big JSON construct to get one probe from one AS each. And if you are a researcher or just interested, you can also get the historical data starting from this year in March, I think. And yeah, get your rankings, and if you want, compare how they changed over time and whatnot. And we also use this approach to make some recommendations of where to maybe place new Atlas probes, but don't have much time to explain that. And I would recommend you look at Pavlo's talk at tomorrow's plenary session, because I think he has a bit more sophisticated approach to that. And with that, I conclude my talk, and I'm happy to take questions. And also, of course, I'm here around afterwards. So if you want to know more details, please also free to talk to me then. Thank you.
Thank you very much. Thank you very much. Questions? No questions? Well, I have one. They told me I should go here. It's again me. So in various parts, you repeated, and also in the presentation, one probe per AS. And my question is, would it be, I mean, how difficult would it be to, and if it would be possible with your approach to have a set of probes per AS, so more than one? What would be the problem with that?
So we thought about that, but that basically opens another can of worms, like for each AS, then how many probes of the AS to choose. What we tried to do, because we wanted to do that, is to have this mesh type measurement between probes of the same AS. But sadly, Atlas probes are not required, or we thought it would be the case, but it's not. So Atlas probes are not required to respond to trace routes themselves, which would be a very nice feature maybe to have to know the distance between them. And so if that would be possible, then you could do a similar thing and just see like, okay, if they are at least this far from each other, we include multiple probes. Because for example, yeah, Deutsche Telekom, maybe in Cogent, you have these very large ASs where it might actually be very reasonable to have more than one probe. Yeah, but yeah, for that would be nice if the Atlas probes were required to respond to these things.
Okay, that's also a feed. Oh.
Not exactly a question, but it's thank you for. I already tried this one because you presented in TMA, so I tried some examples that you provide. One thing that that will be nice in this clustering that you are doing, if instead of just getting a set of autonomous systems, we could get at the end how representative is that cluster when we are talking about population.
Yeah.
That is, it will be very nice, because we know that cluster represents, I don't know, 1 million persons or something like that.
Yeah, that's actually the thing we thought about combining with the AP, I think, population estimates. Yeah.
That would be nice.
But yeah, providing an interface would be good.
Thank you.
Cool. Yes.
Hi, Chris. I'm in from the RIPE Atlas team. Yeah, you're right. The probes aren't required to respond to trace routes, or in general, because they exist in a very heterogeneous set of environments. So that's kind of by design.
Yeah.
Have you considered, or would it be helpful to make use of the anchor measurements, because all of the probes are targeting RIPE Atlas anchors? A large set of anchors, and the anchors always are responding to the probes. Maybe you can get some idea of similarity that way. I mean, you don't have the mesh between the probes, but you kind of have an external reference source. Could be an avenue to look at.
Yeah, it's actually a good idea. So basically, okay. Yeah, no, so yeah, if you have then probes who have similar, I mean, not as precise, I guess, but yeah, so if you have clear differences between that, then probably yes. Yeah, that's actually a good idea. No, we have not thought about that. Thanks.
We have one
question maybe to you and also to the previous question. Would you consider integrating something like this in the RIPE Atlas user interface?
Yeah, I would always consider it, but I know that the RIPE Atlas engineers, I think, have a lot on their plate with RIPE Atlas. So, I mean, of course, yeah, I would be up to it. This is also, so Emil Abin from RIPE also has some part in this. But yeah, that's, I think, not up to us.
I mean, for researchers, it would probably be of little value because you're not doing via that, but you're a regular user that just wants to do an acquire probe set. That would be interesting.
Yeah.
Thank you.
Okay.
audio question. So
Okay, then I'll just quickly respond to that and say it's something we could consider, but it's always a question of like, yeah, exactly which algorithm to use and so on. So there's something we can discuss.
perfect. The good news is also that the audio question, the person dropped out. So we are back on track.
We have one
Thank you very
question.
much for your presentation. Okay, we can go. The next presenter, so now the subtrack finished. The next presenter is Marcel Floors. Marcel is a senior research scientist and head of the research at Edge.io, formerly known as Edgecast. He works on various topics, including caching, routing, and internet measurement. In general, he focuses on understanding how operational systems interact with the internet and how CDNs can be made faster and more reliable. Marcel will present shake alert detecting waves in the internet control plane. Do we have it? There we go. Perfect.
Perfect.
Stage
Can you guys hear
is
me?
virtually yours.
Excellent. Thank you so much. So as you mentioned, I'm from Edge.io, which is sort of the combination of Edgecast and Limelight. So we're two hyper giants on the internet, both very large CDNs with really big content delivery networks, delivering content all over the world. And one of the challenges delivering content like that is that we have really big networks that have a lot of routers, and many routers means many router failures, right? We have hardware failures, we have software failures. We also have lots of providers, right? Both the CDN networks peer very deeply, and that means we have lots of provider failures, right? They have their own router failures, their own software failures, they have physical link failures, right? Every sort of bad thing you can imagine. And even though we do a lot of monitoring on the network, right? We do heartbeats and active measurements, making sure that the CDN is up and running. Any sort of external view you can get of how things are reaching the CDN will always be helpful. So for that, what we're going to look at is BGP update messages coming from RIS Live. And in particular, we're going to look at updates that contain paths with our network as the origin, right? The idea being that these are going to reflect changes on the paths towards us. So you can sort of imagine this little diagram I have here. We have the CDN paired with some networks. We announce our prefixes out. They propagate through these networks and eventually reach some RIS collector. And our hypothesis here is that if something bad happens on the network, for example, our link between one of our providers there is damaged, that will generate a whole bunch of update messages as each of these downstream networks suddenly switches to an alternative path via another provider. And this is going to create a large volume of update messages. Now, in order to test this, we first needed to understand what the sort of regular steady state pattern of updates look like. So what we did here is we looked at the update volumes we saw for 6 different networks, and we grouped them into 1-minute buckets and just counted the number of updates across all collectors. So here, we're not paying attention to what the prefixes are or anything, simply the origin network and the number of updates we see. Here we looked at 2 different CDN networks, what we call a content network, 2 ISPs, and a root letter. So a vast variety of different network sizes and deployments and architectures. And what we see is they have pretty different steady state behaviors, right? With the CDNs generating significantly more messages than the other networks. But what we did also see is that when notable events happen on the internet, this count often increases dramatically, right? These networks see pretty sudden increases in the messages during an event. So what we want to do is we want to capture exactly those cases. So for that, we turn to outlier detection. And in particular, we're going to use a density-based detection algorithm. And something pretty simple here. We're going to look for every new bucket that we fill, right, as time is progressing. We're going to look for k neighboring buckets within a radius r for a time window w. So as long as we satisfy that criteria, we'll consider this a regular update. If we, however, violate that criteria, in particular, we're more than some radius r away from the other points, then we'll declare this to be an outlier and a shake, right? And this will be a sign that there's some disturbance in the control plane. So what we can do then is we can take these live BGP updates from RIS, and actually you can stuff in whatever collectors you like, and we feed them into a system we call the alert aggregator, which combines them with a set of CDN metadata. So this includes things like which CDN sites are announcing which prefixes, which providers are available at each site, information like this. We then output a stream of counts, right, just as a time series, which we then pass through our outlier detection. When the outlier detection finds an outlying point, we generate an alert. So I should mention the Shake Alert system is actually named for the United States Geological Survey's Shake Alert system, which is the earthquake early warning detection system. And that's sort of the same idea of what we're trying to do here. So what we get when we run this whole system is we can actually do what we call likely impact localization. So this is a little bit different than fault localization. So we can't necessarily, and we're not trying to say necessarily where the problem happened, but we're trying to understand what CDN sites may be impacted when one of these events occurs. And by using that CDN metadata, we can say potentially which site will be impacted by changes in routing that are happening as a result. So here you can just see a simple example where normally there's some steady state of updates, but during some significant events, I think in this case, it was an actual provider outage, right? We see pretty significant increases, right, that stand out dramatically. So the sort of final question then here is, what do these events actually mean, right? We all know that BGP update traffic like this can be a little bit noisy. A lot of times it doesn't really seem to indicate much of anything. The collectors and their peers are relatively a separate set than the eyeball networks that are generally fetching content from the CDN, so maybe they don't really mean much. So to answer that, we decided to try and measure events on the CDN side and correlate them with the Shake events. So we considered sort of 4 different types of events. We considered device resets, right, where we actually see our routers reboot, or like a line card or a significant component restart. We look for BGP state changes, right, where the BGP sessions with our providers actually exit the established state. We also look at, for cases of announcement changes, these might be something we would do manually on our side. For example, during a maintenance, we might withdraw certain announcements or announce new prefixes. We also look for good old packet loss, right, something we detect on our active measurements from site to site. Here, we required a pretty significant amount of packet loss to 5 other sites in a nearby time frame. And what we find is that indeed the shakes do correlate with these events, right, with 80% of shakes on average matching at least one of these events. That said, these are a pretty broad set of events, right? These cover a lot of ground. So they don't necessarily, the shakes are not reliably telling you that one type of event is happening, but instead acting as a general indicator that a large event has occurred on the network that you should be aware of. So in this way, Shake Alert is able to provide an entirely external alert system that provides extra visibility to operators. Obviously, we're not suggesting you rip out all your active monitoring and trust only in BGP updates, but rather it sort of acts as another tool in the tool belt, right? Offering another view that is sometimes otherwise hard to get and is complementary to a lot of our existing tools. An interesting note is we found that in some cases, especially where you might be waiting for systems to time out to alert you that something bad has happened, these can happen quite quickly. The other neat thing you can do with this is not only monitor your own network, but you can monitor other networks as well, right? You simply look for different origin networks in the feed, which can be handy sometimes to see when there's turbulence in different parts of the internet. So with that, I'd be happy to open it up to questions.
Perfect. Thank you very much. Thank you for your presentation. It's question time. Hey, Costas.
Hello, this is Costas Zorbadelos from Canal Plus Telecom. Excellent work, first of all. I would like just to ask, I have seen in my small AS currently that especially with withdrawals, RISC-Live sometimes takes a lot of time to send the necessary updates. So did you face in your own measurements any such variance, I mean, big variance in delays, especially with withdrawals? Because
So-
in my case, what I just noticed is that the looking glass in stat in the stat side of RIPE was showing a consistent view, but I got the update on RISC-Live even hours later. So did you notice any such variance?
So I haven't, because of how the announcements work from the CDN, we actually mostly are looking at announcement updates here, and I haven't looked too closely at withdrawals. In general, for updates, there are very weird temporal patterns, which I generally expect are from BGP convergence itself. I think RISC-Live, there are some interesting temporal components, and actually there's a cool blog post on RIPE Labs right now on some recent work improving the timing there. But definitely there are weird temporal patterns where we see some of these events in particular. We'll see a big spike, and then some tens of minutes later we'll see sort of subsequent spikes. I've generally attributed these to BGP itself rather than the collectors, but I don't know for sure.
Thank you.
Chris, I'm the lead developer on RISC-Live. Yeah, I would indeed refer you to the blog post from Oleg, which talks about some of the issues. There have been even more recent improvements and bug fixes, and there definitely were some issues specifically related to RISC-Live rather than the BGP or even the RIS root collectors, which should have been much improved. So I would consider maybe if you were seeing such delays in the past, and this is for Costas or anyone else, I would expect them to be much reduced. So we should be always, sub 1 minute, normally around 3, 4, 5 seconds, something. So yeah, going forward, if you did see delays or weird temporal things, I would be interested if they go away or continue, and yeah, we can discuss. Thanks.
Yeah, I have to say, RISC-Live in general was even before the recent adjustments was pretty impressively quick, considering how much data it's pulling in and presenting. So we found it worked very well for these live alerting purposes, even a year and a half ago. So
perfect. I share also the happiness for RISC-Live, which I also use a lot, and I find in general really quick. In general, in the order of seconds. However, we should go ahead. So we go with the next presentation. The next presentation is Mariano Scazzariello. Mariano is a PhD student at Roma Tre University in the Computer Networks and Security Research Group. It reminds me something. His research focuses on studying data center technologies, including network topologies and routing protocols, and he will present Cadara, a lightweight and scalable network emulation system. Hey, Mariano.
So, good morning, everyone, and thanks for joining this presentation. I'm Mariano, and today I will present Cadara. So, okay. So what is Cadara? Cadara is a container-based network emulation system, and it puts at user's disposal a virtual environment in which you can run real networking software. And in this environment, you can perform tests and experiments on the network. Currently, it is used both in the academic and on the industry side. Cadara is a completely open source project written in Python, and you can find all the source code on GitHub if you want to play with it, of course. And here's some project numbers. Currently, we have more than 50,000 downloads, and many universities around the world use it. So Kadara, differently from other network emulators like Mininet or Container Lab, is compatible with all the main operating systems and Linux distributions. And we also ship a Python PY package if you want to automate the network emulation through code. So Kadara uses a really simple configuration language to describe a network scenario. And basically, the network scenario is a directory on the file system that must contain a file called lab.conf, which describes the topology. And optionally, for each device, you can have a folder which contains the real configuration of that device. As an example here, we have a small network topology on the left, and on the right, we have the Kadara representation. You can see the lab.conf file is just a text file which describes the network topology and the links between the devices. And you also have the directory structure. As you can see, each device has a folder which contains the Quagga suite, in particular configuration, and in particular the BGP configuration of the Quagga suite. Kadara uses containers, as I said, in particular Docker containers, and one of its major strengths is the scalability. In fact, you can have two configuration modes. The first one is the single host configuration mode, which leverages on the local Docker daemon. And in this configuration, you can deploy more than 1,000 devices on a common laptop and more than 2,000 devices on a commodity server. Moreover, Kadara is one of the few tools available to have a distributed mode, which leverages on a Kubernetes cluster, so a distributed physical cluster, in which you can deploy really huge networks. So now I will show several use cases where Kadara is an effective tool. And of course, this is not an exhaustive list. There are just few examples. So the first one is the configuration testing. Since Kadara allows to deploy complex arbitrary network scenarios, you can test network configurations before deploying them in the production network. You can think of replicating a realistic copy of your network inside the tool and then test on it. And also you can test interoperability between configurations, versions, and different implementations from different vendors. Moreover, Kadara emulates networks at layer 2, so you can also run different non-IP based protocols such as ISIS. So this is a simple network scenario, which you can also find on the repository in GitHub. And it implements a simple BGP hierarchy, as you can see, with different policies. So supposed to be an operator of IS-100. You can replicate your network inside the tool. And what you can do, you can test your IGP configurations or different BGP configurations or policies, or also include the different network functions and test them. So what you can do with Kadara is basically everything. I mean, it gives a friendly environment in which the operator can, of course, test everything from the BGP policies, such as multi-homing, load balancing, or implement a route reflector hierarchy, and also completely different things, such as SDN algorithms or configurations. So another possible use case is testing what-if scenarios for security purposes. So what you can do is actually deploy your network and analyze how the configuration changes affect your network, both inside and outside. And also you can replay possible attacks or test possible attacks and test the efficiency of the implemented countermeasures of your network. So this is another simple network scenario with 8 autonomous systems. And as you can see here, we have both some routers and RPKI validators and Krill deployed. This also shows how it is easy to include some novel technologies such as Rotinator and Krill inside the Kadara. And so I will also show a quick live example if the video works. So as you can see here, we have a terminal for each device. In particular here, they are only shown the relevant terminals. And what we are doing is that the client in the S4 is pinging the web server in AS1. As you can see on the top right terminal, we have the BGP control plane of the router in AS4, and it shows that it has two announcements for the AS1 prefix, and it selected the one towards AS3. So I will play the video. Is it okay? So this is the two announcements, sorry. And now AS7 tries to hijack the prefix of AS1 to sniff the traffic. But as you can see, the hijack is not successful because the malicious announcement is RPK invalid. So this is just a simple example of what you can do in Kadara. As a last use case, you can use the Python APIs to build the complex frameworks on top of Kadara. So this allows the operator to build testing pipelines to automatically deploy and assess the configuration changes before deploying them in the production network. So you can think of creating a system where you can emulate your topology, your entire infrastructure, put a change in the configuration, then perform some tests on this network with the changes, and if all the test passes, you can automatically deploy them in the network. And also, it allows vendors to build integration testing pipelines for both supporting protocols and network function development. For this use case, I show Sibyl, which is a system that we developed. In Sibyl, we assess the routing protocol implementations in FAT3 topologies, which are commonly used in data centers. Of course, Sibyl leverages on Kadara in the distributed mode and automatically deploys virtual FAT3s and computes some standard and novel metrics for analyzing the protocol behavior. And we tested both some open source implementations, including FA routing BGP, and also a vendor implementation, which is Rift by Juniper. Rift is a new protocol specifically devised for FAT3 topologies. And during our experiment, we tested the topologies with up to 1,300 routers. And if you are more interested in the work, you can check the paper, which is linked below. So in conclusion, Kadara allows to deploy more than 1,000 devices on a common laptop. It also gives the operators an environment in which they can deploy a huge network with no scalability constraints in the distributed mode. Also, it is possible to emulate networks for both operational and research purposes to test both different implementations, configurations, or what-if scenarios. And moreover, it can also allow to build frameworks for testing implementations and configuration on different and generic network scenarios. So these are some contacts. Kadara is completely developed by the Roma Tre Computer Networks and Research Group, Security Research Group, as Massimo said. We are the three main developers, and below you can find some links about the project and the QR code for the website. So thank you. And I'm happy to take your questions.
Thank you for your presentation. Okay, you go ahead. I also have a question. Go.
It became a habit.
Yeah.
Sorry. What an excellent tool.
Thank you.
It is exactly what I needed. And because I had this need to create some software emulating my environment and all that stuff. Main question, do you support my vendor?
The same question.
Same question.
I had a hard time, a really hard time, and I just emulated VMX with 3 machines.
Okay.
Because of the resources.
So yes, this is one of the main questions that we have actually. So basically, yes. I mean, if your vendor ships a container I don't know if it ships. You can just put it in Kadara as is. We did it with Juniper Rift. They just give us the container and we deployed it in Kadara.
Just the CRPD product of
Yes.
Juniper?
Yes.
Okay, but not an entire mix?
No, but we are working also on an extension of Kadara in which you can do hybrid scenarios with VMs and containers. You can use both.
Definitely catch up.
Okay. Thank you.
Thank you so much.
Hello, to Walter Barr from the University of Strasbourg. Thank you for the great presentation and the great platform as well. I was wondering if you use it for teaching, which I assume you do.
Yes.
And if you do, how do you use it? What is your experience with it? What sort of questions do you ask to the students?
Yes, we use it at Roma 3 in our one of our courses. And on the GitHub, you can find a whole repository with the whole network scenarios that we use for teaching. And also they have the descriptions of the network scenarios and what happens in the network scenarios, how you can change configurations and so on. And we don't have any questions from the students. I mean, I don't know what, we also use it for the examination of students.
So you run like one network and you give it to each student and they work individually on their network?
No, actually,
you try to like make something interactive?
Actually, this is possible, but we don't do that in our course. But we know that some other universities do it to split the network and each student works on a different part of the network.
I actually, on this, I see on your website that you have like more than 10 other universities.
Yes, yes.
Okay.
More than 10. But these are the known ones. Maybe there are more, but we don't know.
No, I think it's good for.
Thank you.
Hi, Colin Petrie from NTT. I have a question regarding the container networking environment. Can you simulate on the links between these virtual devices different levels of latency and packet loss to add on to the link to simulate, for example, a global environment?
Yeah. So actually, in the emulation, the performance of the links are fake, let's say, but you can use the TC tool on the containers, and you can set latencies or packet losses and so on.
Do you have to do that manually, or is there
actually, we were thinking to include this type of parameters in the tool, but we're still working on that. Thank you.
Thank you very much. I think there are no more questions. Thank you for the presentation. Okay, so our next presenter is Valerio Luconi. Valerio obtained his PhD in computer engineering from the University of Pisa in 2016. He's a researcher with the CNR of Pisa. He has been involved in several EU-funded projects. I should have printed in one page only. Related to network performance, his research interests include internet measurement, internet topology, IP geolocation, and network neutrality. Valerio will present impact of the first months of war on routing and latency in Ukraine. Valerio, the stage is yours.
Okay, thank you for your introduction. The work that I'm presenting today is in collaboration with Alessio Vecchia from the University of Pisa. And our objective was to quantify the impact of the activities, of the war activities in Ukraine on the Ukrainian internet. This has been done from two perspectives: routing, to see how did the network adapt to the events of war, both in physical and digital world, and latency, to see if there is a performance degradation, and because latency is one of the indicators that can show how this performance degradation is perceived by end users. So we collected data from 3 datasets from February 14, 2022 to May 7, 2022. So we collected data for 10 days before the start of the war to have a baseline for comparison. The data that we collected was from RIPE-STAT, the routed AESs and prefixes of Ukraine and Russia and their geolocation. From RIPE-RIS, we collected of the BGP updates in the considered time period. And from RIPE-ATLAS, we collected all the anchoring measurements, ICMP pings and trace routes performed by Ukrainian probes. So let's start with the analysis. Here I show the number of routed AESs and prefixes per day for Ukraine in blue and for Russia in orange. And the two vertical lines corresponds to the start of the war and to the start of the second phase of the war, when the Russian troops retreated from the north of Ukraine. For what concerns routed AESs, we can see there is a sudden decrease after the start of the war until a minimum, and then they start slowly increasing back when the second phase is starting. Overall, we counted the 300 disconnected AESs, not all at the same time. So they experienced some intermittent disconnections. We geolocated those AESs, and we found that here in the map, you can see in red the locations of the disconnected AESs, and in blue, the locations of the war activities, including attacks, battles, and bombings. As you can see, there is a geographic correlations between the two. And this, for us, is an indicator that these disconnections could be mainly due to physical damaging or occupation of the territories. Then we consider the routed prefixes of Ukraine. As you can see from the plot, there is a initial decrease and then a sudden increase, even higher than the original number before the start of the war. We got a bit dig a bit deeper on that, and we found that some prefixes that were announced were completely new, and other ones were just prefixes that were splitted in smaller sub-prefixes, /24 or even smaller, even /32. So we believe that this could be an indication of a possible defense over attacks on the BGP side. Now let's focus on the BGP activity. We collected all the updates and divided them into announcement and withdrawals, and we show them for Ukraine in blue and for Russia in orange. So these are the updates generated for the Ukrainian prefixes and Russian prefixes. As you can see, there is a peak in the number of updates corresponding to the start of the war, and just a few days after for Russian prefixes, and a general increase of the activity, especially on the Ukrainian side. The increase of the activity is shared among all the prefixes, but these peaks are not for really all the prefixes. And then there is a bump, which this is shared among all prefixes between March 28 and April 9. We do not know which are the causes of this bump, but we still think it is worth noticing it. Then we considered BGP hijack attacks. We consider 4 kinds of hijack attacks that we found in literature. I will not enter the details because I do not have time, but we did not run a proper hijack detection algorithm, but simply we collected the updates that were compatible with this kind of attacks. So these are just suspect updates. In blue, we show the updates concerning Ukrainian prefixes and which were involving Russian ASs, and in orange, vice versa. There is a general increase of activity when the war starts, especially in the first two rows, which are the suspect cases of prefix hijacks and sub-prefix hijacks, which are the most simple ways of BGP hijacking, and also for the other cases which involve hijacking also the AS, so announcing myself as a neighbor of a target AS. Here the increase is less clear, and from the on the Russian side we can see some spikes but not a proper increase. Then let's consider latency. We collected all the anchoring measurements made by Ukrainian probes, and we divided them into three groups, those directed to Ukrainian anchors, those directed to Russian anchors, and those directed to the other European anchors. We can see that there is an increase of latency generally, and also an increase of the variability of the latency. But what is most interesting is that between Ukraine and Russia, there is a step-like increase, which never goes down. And this corresponds to the BGP activity bumps that we showed before. And finally, we investigated the direct links between Ukrainian and Russian ASs. And as we can see from the plot, after the start of the war, there is a sudden decrease in the number of these links. We collected also the trace routes between Ukrainian probes and Russian anchors, specifically the ones that the source target pairs that were showing the step-like increase. And we saw disappearing IXPs, like for example Moscow AX, and appearing tier 1 ASs. And this could be an indication that these direct connections were dropped and the paths were transiting through other providers. So to wrap up, we can say that war can deeply influence the digital domain. We saw disconnection due probably to physical damages. We saw an increase in BGP activity and also in suspicious activity. We also saw an increase of possible countermeasures to mitigate attacks. We saw an increase of latency, thus performance degradation, and also disconnections between the two countries at war. However, how was pointed out also in other works presented at the previous RIPE meeting and also on RIPE Labs, the internet showed to be resilient. So even if this intense war activity was going on, most of the connectivity was still maintained. For example, 83% of the RIPE Atlas probes were still online at the end of the considered period. Just to mention, this work could have not been done if it wasn't for the data from RIPE, so we believe this is very precious for the community. So I finished my presentation. Our work has been submitted for review at Computer Networks, and you can find a preprint on archive at the link in the slide. And that's it. I will be happy to answer to any questions.
Thank you, Valerio. Thank you very much for your presentation. It's time for questions. So, well, in the meanwhile that I have one for you, actually, I'm curious about two things, going back to the mic. So the first question is, when you say latency, you mean ping only, or you did also other type of measurement?
So we did also other type of measurements. We collected the HTTP measurements And we saw, I don't have the plot here, but it is on the paper. And we saw also increasing that type of latency, both from the average and the standard deviation. So, and especially for the Ukrainian probes towards Russian anchors, we saw that step-like behavior that we highlighted for the ICMP latency.
Perfect. And in one of the last slides, you said that the direct ISS dropped the direct connection. Do you have any more detail about that? That was particularly interesting.
Yes, we particularly see one Ukrainian AS. I don't remember the name or the AS number that was seizing all its direct connection with other Russian ASs, which were a lot. They were like 500. And also we found that mainly the connections that were remaining were established by bigger ASs. Bigger, I mean in terms of customer con, which we gathered from CADA.
Thank you very much, Valerio. Thank you for your answer. You have another question.
Hi, Michael Richardson. I guess I had two questions, but the more interesting one I think is, since you had to get historical data to make comparisons, I'm wondering if there was data you would have liked to have, but we didn't think to collect, we collectively, the community, that would have made your analysis easier or more interesting.
Okay, so that's an interesting question. I didn't thought about it because actually I was just focusing on collecting all that was available at the time. But you know, some useful data could be on the amount of traffic if it could be public, but there are very few sources, and I think that it would not be possible to have it unless we contact privately operators. And
Sure.
The other one, of course, our view is always limited by the number of vantage points and so on. But still, we believe that we had enough to obtain results that are somehow interesting and meaningful.
No.
I think we should go to the next presentation. Thank you very much, Valerio. And of course, other questions can be done offline. And we go to the next presenter, which is in-house presenter from RIPE NCC, Kasim Loon. Kasim obtained his PhD from cybersecurity from TU Delft in the Netherlands. He has recently joined the RIPE NCC as a researcher in the R&D department. He is interested in internet measurement, especially outage detection and routing security. And he has a really interesting presentation. I let you announce it. The stage is yours.
Thank you, Massimo. So, RIPE NCC has run out of IPv4 address. Well, we know this for quite a while, right? We can still get IP addresses if we go to local brokers. One IP address, which I found from a booth outside yesterday, is around $50 US. So today, I want to talk about 268 million IP addresses that are still unallocated. My story starts pre-1993. Maybe some people remember classful IP addresses. We had class A, B, and C as unicast, D as multicast, and E as reserved for future. As we all live in present, there was no future, and still probably is no future. So class E became 240/4 inside the notation, but remained reserved. There has been several discussions to repurpose these addresses as unicast addresses or private addresses. So two IETF drafts were proposed. V. Fuller et al. Suggested to reclassify 240/4 as unicast address space, while Wilson et al. Suggested redesignate from future use to limited use, that is extension of 1918 RFC, and make it as a private use. Both of them did not progress as an RFCs, and the opponents noted that the demand for IPv4 is so high that hundreds and millions of IP addresses will be exhausted in no time. It's better that organization now moves to the newer version, that is IPv6. So, but there have been reports that the 240/4 block has been used unofficially. So we looked in our RIPE Atlas probes data to find this in the wild. We took a snapshot of a single day and we looked in traceroute, ping, and DNS data. There were no results in ping and DNS measurements. However, we did find 14.4 million traceroutes that had one or more hops that contained 240/4 IP address. Almost all the traceroutes originated from two Amazon ASs, AS16509 and AS14618. An example of traceroute looks like this. So we see very earlier on in the traceroute, we see 240/4, which gives us some validation that what we found is correct. That is, these ASs are actually using 240/4 address space internally. We also performed some active measurements. We had a website, milways.tat.net, from one of the contributors that resolved to a 240/4 IP address. As expected, we found 87% of traceroutes towards this IP address had timeouts. But 34 probes were able to resolve this, and all of those probes were hosted in AS701. It was very similar with the Amazon ASs, that they were like 1 or 2 hops away from the probe. So that gives, again, us a validity that this is actually Verizon Business using 240/4 internally. So I don't have a lot to say, but I want to conclude that this work has a lot of limitation. We looked at the single day snapshot, and also we did active measurement for only one IP address. But nonetheless, we found that there is actually at least 2 cloud providers and bigger ones are using 240/4 internally. We expect to find more hints if we look more in the data, and also in the future internet measurements data. And if left unchecked, it will be challenging to assign this address if there is a future for 240/4. So I want to turn it around and ask these questions. Why are these network providers using 240/4 internally? And while I think majority of the people in this room and overall network community agree IPv6 is the future, and I want to know, why is there still a market for v4? And why are hyper giants like Amazon and Alibaba investing heavily in buying more IPv4 addresses? And do you think, is this a problem, or does this problem need attention? So we did had some discussions in it. I asked for a very limited time, so I don't have time to go into the details, but you can read our labs article where I tried to discuss these questions and try to answer some of them, but I'm very much looking forward to, from the community, that what do people over here think about this? It was also posted on Hacker News. There's a interesting debate, v4, v6. I would highly recommend reading it. It reached to the front page, so got a lot of people interested in this topic. That's it. I want to open the floor for questions. Thank you so much.
Thank you very much. There we go. We have the first question.
My question is, do you think, or I think that the more effort we put into extending IPv4 space, the less demand for IPv6 will be over here. Yeah, from the customers, from the providers, from the end users. So it's nice we have such a block over here, but I personally tried several years ago to propagate some part of this block just for tests. And I found it's pretty often impossible from some platforms because they still check the type of an IP address, and just the TCP stack has been blocking sending of such announcement of sending of such packets just from those box or to receive them on such a box. So we still need to change a lot of software to be able to use such a block, and it's probably much better to invest to IPv6.
That's true,
Yeah,
but there is a Unicast project. They are looking into like patches and other things, but I as a proponent of v6 myself, so I have nothing for that, but I wanted to see because it's out there, and if you look at Unicast project, I've also referenced them in my work. They're also trying to propose an RFC around it, so that made me interested to look into that block. Yes.
Hey, Malte Tatelo, IIJ. More a comment than a question. So for these probes, these 30 something from AS701 that reached some weird target, we should follow up afterwards, because I think that's not specifically your targets, but we saw in some of our measurements also that you have a large number of probes, none of them reach your target, but AS701 have 250 timeouts and then a reply. So I think that's maybe a problem with the probes or network configurations there, and not specifically actually reaching something, but more like a...
Yeah, we can follow up, but it was like first or second hop, and then there is the trace of...
Okay, yeah, let's check that out. Thanks.
Okay, yeah.
Michael Richardson, I just could say that there's a large number of cloud providers that say they support IPv6, and then you throw Docker, combine it with Docker, and you find yourself with an IPv4 only network. And it's very sad, and that's one of the reasons that's pushing people to say, oh my God, well, we'll just get a v4. But it's an internal process. We don't need v4, but we wind up with a v4, even though it's me talking to me, and I could do it over v6, but they won't let me. But really, I think the interesting thing is, I think we should get one of the looking glasses, like the internet telescopes, etc. Those people, I think we should get them to announce this address space and see what happens.
And see
Yeah.
who...
Yeah, and I think if nothing else, it would solve the problem of, you know, people squatting on it, okay, because suddenly their packets would go somewhere else,
yeah,
and that would be a surprise to them. And we would also, of course, have more statistics as to maybe who's asking, right?
That
So,
I think is an excellent idea. I would definitely like to catch up on it.
Thank you for the question. I on the cloud part, recently a cloud provider told me, yeah, we do IPv6. When I asked why I cannot set up my reverse DNS, they told me, no, we don't do that. That was not possible to, for some reason, only IPv4. Anyway, so thank you very much for your presentation.
We
have one. I think just closing remarks, we are on time. That's surprising. Perfect. So let's go just to, well, basically the closing remarks are this. Okay. First of all, remember to vote for the presentation. And if you have feedback, send the email to the email of the chairs. And in particular, we would like to increase the interaction in the mailing list, which recently has been a bit low. Please, if you have ideas, if you have measurement you want to share, or also this discussion that we did today, please share it in the mailing list. And with this, we are closing, and see you in Rotterdam.
Hello? So, excellent. Good. Is that okay?
That looks good. Looks.
Okay, great. Thank you for that. I'll stop sharing now tonight.
Will be open, when you start, we will open. Yeah, I can open, or you can control whatever you open. Yeah. Okay.
So it's 11 o'clock. Maybe we can start. We have a packed agenda. So my name is Santosh Balakrishnan, one of the chairs for the RIPE IoT working group.
Yeah, good morning, and I'm Peter Steinhauser, co-chair of the RIPE IoT working group. As Santosh said, we have a pretty packed agenda. So just let's jump in. Before we start, I wanted to thank our scribe for today, Aifa, I hope I spelled your name correctly. Thanks to Alan from RIPE NCC and Menno for the technical support. Thank you so much. Okay, so let me see how this works. Okay, so this is actually the slides for Michael. Could I have the, okay, great.
I'll restart this.
Okay, so this is our agenda for today. So first we start with housekeeping. Then we have 3 talks. One will be done remotely from Nick Allard. He couldn't come to the RIPE meeting this time. So very quickly, housekeeping, as said, we should cover the meeting minutes from the previous RIPE meeting. I hope you had a look at it in advance.
Is there anybody who needs to update, or do you think it's okay? We can validate the agenda minutes?
Yeah, looks okay. Great. Okay, so also a quick note, we have a code of conduct for the RIPE meetings, which was approved. So please, everybody get familiar with the code of conduct and act accordingly. So this is also something we should say. And very important for the Q&A sessions after the talks, go to the mic, say your name and affiliation, and then ask your question. So everybody knows who you are, whom you're speaking for. Thank you. Okay, for remote participation, please make sure that you use the QA window, not the chat window, to ask your questions. And for the rest, as usual. All right, so then let's start with our first talk, done by Michael Richardson from Sandelman Works. Thank you.
I click on here? No, you have the clicker. Okay, I guess I need the microphone. Hi, so I'm stuck to the microphone. My name is Michael. I'm here to talk to you about an ITF document, an IRTF document that has some relevance to IoT and trust, and actually for that matter to RPKI. Are there any RPKI enthusiasts in the room? They probably went somewhere else. Oh yes, we have one. All right, so you might care about this as well. A little bit about the talk. I'm going to tell you who I am, why we're here, the challenges about this problem, and some of the results that I have so far. And then what I really want you to do is to line up the microphone and tell me why I'm an idiot and you have a better idea, because I'd much rather you did the work than me. So who am I? I've been involved in the internet since the 1980s. Been involved in a whole bunch of startups and this kind of thing, and I spend most of my time writing RFCs involving security and IoT onboarding. Well, it's interesting. So I was just sat through the metrics working group, and I think it's really important. You know, if you tell me this quote here, tell me how you will measure me, and then I'll tell you how I'll behave. And this is usually attributed to Eliyahu Goldratt, who died recently, or not that recently, a while ago. And he wrote 2 books. If you haven't read them, I highly recommend them very much. And some other books were written in the same style more recently about DevOps. And these aren't dry business books. These are novels about people who have adventures that happen to involve scheduling and software. So there's like things that you could read, you know, at the cottage and then not actually realize you were learning. So that's something new. But I'm not here to talk about their things. I'm here to talk about my document. And it's called a Taxonomy of Operational Security Considerations for Manufacturer Installed Keys and Trust Anchors. That's a bit of a mouthful, but there's the QR code that'll take you there. So now you all need to take out your phones and you need to put that on your reading list. And you'll also notice that the URL is at the bottom of the slide now. So you have no excuse for not knowing where the document is from this point on. That's a bit what it looks like. And I'm going to tell you why I came to write it in the first place. So, you know, of course, this answer to all security problems is cryptography, right? Can we just go home now? Okay, that's the answer. There's some stuff there, you know, and someone will tell you why AES 128 is better than, or what 256 is better than 128. And the reality is that's completely irrelevant, because what it matters is about how you trust and who you trust. So let's just say you're the principal of this Japanese school, and this thing shows up on your sidewalk one day, okay? The original IoT device is a Coke machine, and this one has legs and arms and apparently does facial recognition and knows which drink you like. And so you have a couple of questions about the safety of this device as it's wandering around your schoolyard, okay? You're not actually sure. It might be a human inside, but you really don't know. What if it has a refrigerant leak, right? It's going to poison the kids, maybe. You might be concerned about that. So you might want to know something about, recent maintenance facilities of the software, okay? You might want to know, has the refrigerant microcontroller been updated lately to the latest specs, okay? Is there a remote attestation maybe that says it's been inspected lately and that there is in fact no leak, right? How would you know that? Well, of course, it's not your Coke machine, it's someone else's Coke machine, and even if it was yours, the MCU that controls the refrigerant is probably 3 layers of supplier down, okay? So what are you gonna do? All right, so what about the facial recognition? I mean, your students have some privacy. Is the facial recognition running locally in a container, or does it send it all up to the cloud somewhere, right? How can you know which is which? And can you get some kind of a statement about this? How can you find out? And the answer is mostly you can't, okay? Because these are not open to you to inspect, okay? How can you even know if the key was any good? This attestation that says that there's no leaks lately. How can you know that key was a good key and reasonable? So what do we typically do? Okay, so you have these private keys and they relate to certificates, and you worry about the safety of these things and how they're doing. So, okay, so we can put this one into a secure element or a TPM of some kind, and we can have some better assurance of the physical safety of this key. On this end, we can put it into a hardware security module, and we can say, okay, all right, so everything's good now. Well, maybe, okay, so probably that's a stupid way to arrange things. Probably actually you should have 2 keys, one of which you keep safely away in a vault, and one of which you use on a somewhat regular basis in the factory. So for instance, imagine that you have a factory that's creating devices, and every time it creates a device, it creates a new identity certificate for that device. Well, you have to have the key that signs that certificate, the IDEV ID, online. So that's what it might look like. Okay, so first question, what is this architecture called? Any ideas, any suggestions? Sandosh? It's a public key infrastructure, but specifically, what's the metric that tells you that there's 2 certificate authorities there? And this is the number 2, or 1, or 3, or 0, right? So it turns out no one actually has a metric, and that was the whole point. And this is what led to some of this document. One of those questions is, what is this? And we're going to come back to that question there. There might be a trust anchor. So we all talk about in IoT, and in fact, it's in some ETSI regulations about the need for software updates, and they need to be signed software updates. And we even think about now it needs to be post-quantum cryptographically signed software updates. Because if there's a quantum event, we're going to use new software, and you can't use the broken algorithm to upgrade your software. So what do you know about this key? Who has access to it? Who can issue a software update? Or maybe a question in a more ripey kind of thing is, who can update your RPKI is another question, right? And how would you explain that to the board of directors of the company? Okay, and more interesting question, what if those people get wiped out in a tsunami? Or maybe they're on the wrong side of the Russia-Ukraine border, or maybe pandemic means they can't travel and get together again, or there's a whole bunch of situations. What happens? Okay, you have to ship a critical software update, but a bunch of your people have no power, have no house, and they were required to do this. So what do you do? And how do you know that situation? How does that guy back at the school know whether he can get a software update for the refrigerant on a timely basis, even though, you know what, there was a tsunami that happened? Should we just accept that, you know, it's okay for autonomous cars to not get software updates when there's a tsunami? That's would be an interesting take. We need to do that. So you go to add some questions, right? And can anyone see the animal behind that thing? Do you know what it looks like? Do you know the story about why the people, they all look at the elephant and they all came up with different things because they were all looking at a different part of the elephant. None of them saw the whole elephant. And this is the case we have. You don't get to see the manufacturer's whole story. They won't show it to you because they're scared, because their lawyers are scared, because they have actual business reasons why they don't just publish it. So you get little bits here and there and mutters of things of what they might have, and the rest of it's hidden behind a non-disclosure agreement. So what are we going to do? All right, so the first thing that this document does is it says that architecture you saw there, okay, this is a PKI level. This one is 3. There are 3 levels in this thing, so it has a PKI level of 3. Not, we would do it counting from 0. We would say 0, 1, 2, which would be nice because a self-signed certificate has no trust and therefore it should have 0 trust. But it turns out if you talk to some people that that's not easily communicated, and so we'll count from 1. So this one has a level of 3. The end entity certificates are at level 3. Therefore, that's something new. So you now know how to talk about the diagram in the previous thing, and this is what this document is about. Okay, so the other question that you might ask is, how was that private key generated? Did it happen on the device, and then we did some kind of certificate enrollment protocol? Did it happen in the factory, and then we loaded the private key into the device through, for instance, it could happen during testing when it's on a bed of nails test? Or there's a more complicated situation where it turns out you actually outsourced part of the problem to the CPU vendor, and they put a 256-bit random key in it, or maybe it's a puff, if you know what those are. And you were told there's this magic key that's in this device, which you know about and the device knows about, and therefore you can come up with the same private key, one in the factory, one in the thing. If that sounds a bit complicated, it is. And if it sounds a bit suspicious, then yeah, I'm a little bit suspicious too, but it seems okay in many ways. But the question is, what is it even called? And could you at least tell me which one you did? So when you do get that device, that refrigerator, that Mattel Barbie, or that, you know, smart lock for your front door, you maybe would like to know how that key was generated so you can know what faults are there. And I'll just say there's a Dan Bernstein paper from a decade ago about a flaw in the Taiwan smart card system where they're using 1024-bit RSA keys because that was current at the time. And it turns out the private keys weren't really random. And he determined this by looking at thousands and thousands of public keys and realized that there was a pattern, and that he was able to do this to derive essentially all the private keys from the public keys because the random number generator in the factory, because they were using number B, was not properly initialized. I think they replaced all the keys. It was time to do it anyway, but anyway, you can look that up. So who has control over the private key? So the typical thing is that you take a key and you do what's called a Shamir secret splitting. SSSS, it's often called. And what happens is that you get essentially maybe 5 keys. So if you remember grade 10 or 11 high school math, you can remember, you know, you have 2 equations and 2 unknowns. But if I write down 5 equations in 3 unknowns, then I can have a situation where I only need to have 3 of the people present, and I can figure out what the 3 unknowns are, and then I can put the keys back together. And it doesn't matter which of the 5 show up. So I could divide it by 5 pieces, and then I can have 3 people present to unlock the key. Or it could be 4 of 7, or could be 6 of 9, or something like that, okay? Now you have to ask your question, okay, so which of those 9 people, who am I gonna pick? How many on each continent? Might be a question you'd ask. Who can know who those people are? So that's one of the things that I think probably I don't think they should reveal, that should be under NDA. I don't think me as a customer need to know who actually possesses those keys, okay? Those people who possess them are under threat. They're under threat of essentially some kind of extortion that would force them to you know, divulge the key in a way. How many do you need to threaten? Well, if it's 6 of 9, you need to threaten 6 people in order to get the key to be revealed. Okay. Should we even talk about the number 6 or the number 9? I don't have a conclusion on that. That's where I really would like to think. I think that we could safely reveal 3. 6 minus 9. There are 3 spare people. That would be a reasonable thing. And you could also say there are 3 spare people and I can reconstruct the key on 2 continents, maybe. You could tell me what they are so I can know if a tsunami matters. This is a place where I'm much less sure about what to do, and I really would like a lot of feedback of what you think. I mean, there's a real business continuity question here, right? I mean, if you lose the key, not because a bad guy stole it, but because you lost the key when the building burnt down, what do, right? If you've embedded that key into 1 million devices that you've shipped, you have 1 million dead devices. Now you're going out of business, okay? Or something bad is happening. They're not getting security updates or something's going on, right? So that's actually a bigger risk if you think about it to the business than a bad guy getting the key. And that's partly, I think, why we have often bad security processes, because you think about the risk benefits of the whole process, or the refusal, for instance, people refuse to DNSSEC sign their stuff because they're afraid of, what if I lose the key? Now I'm screwed, right? And so this, I think, applies to all of those kinds of stuff. And I went through most of these pieces already here. So what my goal is that you could hire an auditor who could go and find out and sign the NDA and find out the details behind there. And then they would reveal to you a set of standardized metrics that I could then say, vendor 1, you know, has a PKI level of 3 and their resilience number is 4 on 2 continents. Oh, okay. And then I could find the same thing about a different vendor. Oh, they have a PKI number of 1. Okay, which means that they just have a key that they just keep in a drawer, I guess, and on a USB key in a drawer, and they have a resilience number of 0. If they lose it, they're toast, right? Well, that might be okay. That might be an okay, acceptable level of security if what we're talking about is a talking doll. It may be a completely unacceptable level of security if we're talking about the software update key for an autonomous vehicle, right? Which is better? I'm not making an appointment, but until we have a way of measuring it, we're not even going to be able to say which is better or appropriate. That's about it. Questions? Come to the mic. I see many heads out there.
Okay, so we have a lot of time and we could have a lot of questions.
Awesome.
Please say your name and affiliation.
Benedict Stockermann, Stepladder IT, talking for myself. You missed something.
Okay.
The number of auditors.
Ah, so I can have different auditors, or?
Basically, if I want to compromise your system, I just go for the auditor if there's only one.
Okay. How? But the auditor is simply telling me whether the organization is following their processes.
Yes, and then
right.
I buy the stuff, and it does, and the manufacturer doesn't.
Oh, so the manufacturers. Oh, I see. The manufacturer buys the auditor.
No,
yes.
No, somebody. Well, whoever. Yes.
Yes.
But,
okay.
It's and when it comes to the numbers, there's something else. We have X509 certificates,
yes,
and we have certificate authorities, and I don't know how many tens or hundreds of thousands of them. And we know from experience that these don't always do their job. So there we have really the problem. If any one of them screws up, basically the entire system is broken. And as such, you might say it is. And on the other hand, if you say we have one CA, which people really take care about, there is some government or whoever applying whatever pressure they need.
Right.
Do you think that there is sort of a sweet spot where the numbers actually make sense and beyond which they start to get counterproductive?
So I think it's important, first of all, to your first point, or your second point, we have Web PKI CAs that are involved in the CAB forum, and those are one set of things. That's what your web browser trusts. Okay. Mostly to a large extent in the IoT space, we can't use those. The lifetimes that are enforced are too short. The policies are wrong. So in most cases, manufacturers, for the purposes of producing a birth certificate or an IDEV ID, they're talking about spinning up their own private PKI in their factory and doing that. And then they're also talking about the opposite, which is the trust relationship where the software updates happen. And those are also usually, we don't need a public CA for that. You could go to one, you could hire DigiCert or blah, 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 to run that for you. But you don't have to. So in that sense, the number of CAs that we're going to have in the future is not, you know, 37 public ones, but thousands and thousands of private ones. And so that's what I'm really concerned about is that part. I think that your point about the, you know, the public CAs and they can screw up and issue Microsoft.com, which happened, we know, and that whole certificate transparency problem, that's an interesting problem, but it really only applies IoT devices that exclusively call the cloud using a public anchor.
Okay, fair
and
enough.
that's not always the case. You don't have to use a public anchor for that.
Okay, thank you.
Okay.
So do we have any other questions?
Yeah, don't be shy. The URL is still at the bottom there. I would really love your comments. I really need your comments. Essentially what I was told is that there's no point in going forward with this document if it doesn't have a very widespread review. So please read it. And even if you just say, yeah, looks good to me, I would really love to hear that, especially in a public way. So thanks a lot.
So I have a question here.
Oh yeah, you have a question.
Santosh Balakrishnan, AFNIC. So we were talking about the private PKI and the certificate authorities. There is a work going on in the DANS working group at the IETF where they're looking at how DNS could be used as a public key infrastructure for IoT. So my question here is that whether with the certificate authority infrastructure and the DNS as the PKI, is it possible to reinforce the auditing for IoT?
No, I don't think so. So what we're really interested is not how does the public key get to the relying party, which in, you know, X509 is through a series of certificates and CAs and subordinate CAs. And in the case you're talking about, it's through DNS and cert records and DNSSEC records, okay? What we're really interested here is what is the care that the owner of the private key took to make sure the private key stayed private. So in the device, if we're talking about DANS with client-side certificate, client-side TLS authentication, then the private key is going to be in the IoT device somehow, right? So, you know, the stupidest way is just sitting there in Flash and you can just pull the Flash out and read the private key out, right? The other side of it, which is way more complicated, is that there's, you know, an FTPM inside the CPU, and it has the key buried 3 levels down, and, you know, only the maker of the CPU could ever break it, right? Or you'd have to, you know, you'd have to take the one at a time, you'd have to take the CPU apart and you literally sand the silicon off. That's what people do. And then they take a picture and then they sand some more and they can actually recover the data that way. But beyond, like, that's two levels of completely opposite levels of security, right? And so what we're really asking is, tell us where you are in the spectrum, right? Because I don't want my medical equipment having the key that's just sitting in Flash. On the other hand, I don't necessarily want to pay, you know, top buck for, you know, my talking Barbie that doesn't really need that much security, right? Any other questions?
Okay, thank you, Michael. So the next presentation is from Peter Steinhauser. Peter.
Yeah, thank you very much. Hope you can hear me. Okay, great.
10 more minutes if you want.
Pardon?
You can take 10 more minutes if you want.
Well, let's see how it goes. Anyways, first of all, thanks a lot, Michael, for your very interesting talk, because this is about trust and onboarding IoT devices. What I'm going to talk about is a little bit more on the management level. So, I mean, MAT is something we talked about many times on the RIPE meetings already, in talks, in private conversations. And well, what I'm just going to talk about is another approach to solving the missing S in IoT. I think everybody's familiar with that famous talk a couple of years ago. So let's have a look into this. First of all, a disclaimer. So the focus here is more or less about home IoT, not industrial IoT. Of course, the technologies underlying could be used for industrial IoT as well in any case. Anyways, so home IoT, we still have the same challenges. We put a device in the network. The management software still has a life of its own. The device is talking to some places in the internet. We have no clue. The user has no clue what's going to happen. So those devices are penetrating firewalls, establishing random connection with some servers somewhere, and randomly go crazy and evil. And I think most people don't want that, right? So many years ago, some very smart, wise people came up with some ideas and said, okay, let's just go and define what a device is supposed to do on the network level. So they were talking about how to structure this information, which format to use. And of course, the source of the device should provide the file. Yeah, makes sense. And they called it MUD. Well, nice idea. The name actually was not so misleading because so far, well, this is how it looks like today. Okay, just kidding. It's really a great idea to do it that way. The format is very simple. It's human readable. Using kind of a JSON syntax, you can transform it into different formats. So very flexible approach. And we have an IEEE standard for it. So something everybody can rely on. But we still have the chicken and egg problem here. Because at the end, where is the incentive for the manufacturers? Yeah? We have MUD, everybody could use it, but which device is shipped with MUD files in the home IoT space? Because everything here is about cost. So we don't have regulations from the governments. There are conversation with them, there are conversation with the carriers, with the ISPs, but nobody's really willing to do something about it. So there is no unified approach to this concept. And maybe, well, let's try to do something else. And now I'm switching to OpenWRT. So OpenWRT is not really in the focus of the RIPE, but it became over the years a de facto standard for CPEs and home gateways. You don't meet the name very often in the industry. If you talk to chipset makers, they talk about their BDK, Broadcom, their QSDK, Qualcomm. But if you look into it, it's OpenWRT. So keep in mind, per year, we estimate 200 to 300 million devices with OpenWRT or forks of OpenWRT are being shipped. And so maybe this could be a point where we can introduce some technology that can help. So as a kind of a side work in the TIP Open Wi-Fi project, a little piece of software was developed it's called UNet ACL. So people familiar with OpenWRT know that these daemons, microservices in OpenWRT all start with a U for micro, net, of course, network, and ACL, access lists. So the UNet ACL was built to perform a couple of tasks. It can do client detection using DHCP snooping or also static configuration. It can do client MAC IP tracking and can also, if a client is not recognized, registered, can just enforce that the traffic is discarded. It can enforce per MAC bandwidth limits, full traffic accounting, traffic limits, etc. The whole technology is built upon enhanced Berkeley packet filters. The advantage of using eBPF is that you technically have zero CPU cost. So especially on small devices, this is a very important factor. And it's a very, very flexible concept. So originally, the goal of Unit ACL was to do captive portals. Yeah. The best example is, I'm not sure if you're familiar with this, in the CPE industry, we had COVA AP for, I don't know, maybe 15 years. It was something everybody was using. Problem here, the whole implementation was a little bit outdated. So even on a gigabit line, you maybe get 40 megabits throughput, which is not really satisfying. With Unit ACL, you get, well, on a gigabit line, the theoretical roughly 900 megabits per second, which is what you want to achieve. It can be used for parental controls. And then, I mean, the developers came up with the idea, well, we could also do something about this for IoT. So Unit ACL is able to track interfaces and then apply rules and classes that can be attached. So with these classes, you can rewrite the egress, the outgoing interface. You can rewrite destination MAC, add firmware marks, add remove VLANs. So those client mapping rules then can be used for any protocol port, destination IP, etc., any combination. And if you look a little bit about what you can do with it, yeah, just switching back, so protocol port, destination IPs, DNS snooped. This actually looks like a MUD file. In a MUD file, you have this set of descriptions, what a device is supposed to do, what it's supposed to talk to. So why not using the technology of Unit ACL to work with MUD? So the implementation currently for Unit ACL is in the works. It's ongoing. The first step is that you can say, okay, we have a certain device class, we have a certain device, and we have a matching MUD file. You simply use the MUD file, hand it over to Unit ACL, and it applies the rules. So the device can only work in the context that was originally defined in the MUD file. But there's also an important other aspect of it, because Unit ACL also can do the monitoring. And the monitoring part is actually really, really important. We had some conversation with ISPs about network health. And if you did look at the latest attack vectors botnets were using, the critical question is always getting aware of something's going on. So ISPs and carriers tend to do central management of devices, and also OpenWRT or OpenWRT-based projects like in Purple or in TIP, they have central management, central monitoring, telemetrics. And imagine there is a new attack vector for a certain IoT device type. And now the CPE recognizes, okay, there's something going on that's not meeting the specification of what the device is supposed to do. Then it can send a telemetry event and say, okay, there's something weird going on. If this only happens for one customer, not a big deal. But what happens if the same thing happens on hundreds, thousands of customer places? Then the network operator can take this information and say, okay, we have an attack vector, we have to look into it, we have to act. And not, let's say, after 2 or 3 days when the network starts to get a little bit flaky, then they start investigating it. So this is one of the capabilities. And another capability is also that devices that are not registered in the network, you simply discard the network traffic. So the device is there, it's kind of in the network, but it cannot do anything. Okay, this is something I would talk with Michael about it very shortly.
we need some more discussion because, of course, in the device onboarding phase, something needs to enable the device at least to communicate for a certain time. Otherwise, the device says, okay, I cannot reach my gateway, I cannot reach my control server. So it just suspends activity and says, okay, start over again. All right. Anyways, with us, we are close, but still no cigar. Because as I said in the beginning, the challenge here is the chicken and egg problem. So we need MUD files, but we don't have them, especially in the home user field. So the developers said, okay, let's do something we call MUD auto learning. There are several projects who are already doing this, but we wanted to bring it into OpenWRT. So it's available to everybody who's using OpenWRT as a firmware base. Technically, it's quite simple. So unit ACL is monitoring the traffic patterns of an unknown device for a defined time frame. This is still something we are working on. What time frame is necessary? We will connect with other research facilities to find the right parameters for that. Nevertheless, after the learning phase, you have an output of what the device was doing in this time frame. And this then you can export as a MUD file or in any other file format you want. And this you can then use as a foundation to build databases of devices. Is this the ultimate cure for? Of course not. I mean, this is technology, yeah, which can be used for something, but at the end, what we need is a community. It's people who say, okay, we want to use this technology, we want to collect data, we collaborate together to build those device descriptions. Fortunately, there are many people working on that. So I'm positive that this could be a step forward. Maybe also as a side note, since this technology is getting into, for instance, the TIP Open Wi-Fi project, there at least is some industry interest to get those things accelerated. Yeah, and that's my very, very little short intro into Unity. So questions?
Thank you, Peter. So are there any questions for Peter?
Oh, yeah.
So tell me a bit about how long, Michael Richardson here, tell me a little bit about how long you are watching the traffic and how do you become confident that you've seen all the behaviors that you're going to see?
Yeah, as said, that is the real tricky question about it. Yeah.
Or is it possible to relearn, or what happens when there's an alert?
Well, at the moment, the concept is about, let's say for instance, we monitor the device for a day, and what happens during this day is used as a, let's say, initial collection of information. Yeah, I mean, this is the idea is just to have something to start from. So even, let's say, a home user, he gets his new, the famous example actually, his new Samsung TV, and then he says, well, does this Samsung TV need to talk to Facebook? Really? I just want to watch TV, right? And one approach here is to say, okay, the user can say, okay, this device does a lot more things than I wanted to do. So I start the auto learning mode. Then I get a user-friendly representation, let's say it talks to Facebook, does this, and the user can say, okay, I don't want this, I don't want this, I don't want this. But this would be an individual approach. Yeah. But of course, you're totally right. In case the behavior changes, I mean, the behavior change can have a good reason. Yeah. And this is actually in general for MUD files and for this device description, the interesting part. How do we maintain them? Yeah? It's not only about creating the files, but we have to maintain them. We have to see what happens. Software iterations, ports can change, addresses can change. So there are many things that can happen.
So that's the user-focused, the home user-focused side of this. But you're also doing work on the ISP side of things. Would ISP, and you said something about ISPs would get alerts. And that scares me. I think that it scares, I suspect it would scare ISPs because false alarms are so expensive. And so do you have any ideas where how that's going to evolve?
Well, ISPs, frankly speaking, is a very interesting field. I had several talks in the last weeks, and the bad news is most of the ISPs still have no clue how to approach IoT devices. It's they have no clue on the technical side how to do things, what they want to achieve. On the marketing side, they don't know how to monetize it. So to me, frankly speaking, it looks like we should tell them what they can do with it, which is not our job, actually. It's not our job. Yeah.
But someone has to have an opinion, is what you're saying. We might as well form an opinion, and then they could disagree, but at least we're having a conversation then at that point.
Right.
Yeah.
And it's a really good topic, Michael. I would suggest, I mean, we did in the past the first BCOP document of the RIPE IoT working group, and it was a good starting point, like a collection of ideas, things we have. But maybe we should really do a second iteration of the document, or maybe another document, which is like focusing on ISP use cases, yeah, to give them an idea. Yeah.
I agree with you. I was going to say that exactly, that maybe we should have a new document. So we're on the same thought here.
Yeah.
Okay, wonderful.
Thank you so much.
Martin Winton, NetDev. Can you, so sorry, I missed some of the earlier discussion on Martin previous, but can you tell me what's the current state actually? If somebody wants to try experiment with this, in what shape is something available these days?
So the unit ACL itself is already there. I can point you to the repos. The IoT part is currently in implementation. So I think we will have a first running version end of the year.
And for the outdoor learning, is there something experimental code possibly to see where that's going, your own experience?
Well, as said, this is still under implementation, but I can connect you with the head of development who's doing this part of work. I think it's going to be available in the next 6-8 weeks.
Okay, thanks.
Thank you so much, Martin.
Any other questions for Peter?
Okay, thank you.
So I have one for you. Okay, Sandesh Balakrishnan from Afnike. So do you have an idea what is the percentage of IoT devices that have been implemented using OpenWRT?
IoT devices using OpenWRT, I haven't heard about those, because I think the resource requirements are way too high for a common IoT device. I mean, it would be possible to, let's say, to run a surveillance camera, for instance. The hardware would be powerful enough. But for the typical type like power plugs, sensors, etc., OpenWRT is not the right software platform.
So it will be used in the gateway end?
Yes, yes. It's in the gateway. That's the main purpose.
Okay. Thank you.
Thank you.
Hello, my name is Edwin Veul. I work at SURF. I mainly hear you talking about ACL, so like source destination IPs. Have you taken any DNS resolvers in place?
Well, the concept of unit ACL is also covering DNS-based requests. So you can also say, okay, we're learning what the device, which DNS addresses the device is contacting to create the profile and also to enforce rules.
Sounds good. Thank you.
Thank you.
May I also answer that?
Of course.
Michael. So the question of devices that you want to write MUD ACLs on DNS names is a complicated one. And yes, there's an IETF draft for that. I'd love your comments on it, but fundamentally it amounts to you'd better make sure your IoT devices do not do DOH to Google or Cloudflare, because then you can't learn what names they looked up. And more importantly, when you look up the names in the ACL, you might get a different answer than they did. And then your ACLs don't work, and then you get false positives, and then the ISP bitches, and then MUD gets turned off. So that's a kind of the scenario is that then we wind up back where we are now, right? So this is sort of the negative side. DOH is wonderful for personal privacy, but it's unclear if my thermostat really needs that, and should just use local DNS because that's way more private than anything else. And the question is, what can we do to make local DNS so reliable that the IoT vendors would never think about going outside of the home for DNS, right? And I think there's a bigger discussion there, but like it does impact us, right? And you can't do malware. Most of the malware, what are they called? Network nannies that look for malware on your network. Most of them are based upon looking at the DNS requests that certain requests are for malware command and control channels. And when you see that, the device has been compromised. So if you can't see that data because it's all encrypted to someone else, then there's a problem, right? So.
Thank you.
Thank you, Peter. And a round of applause for Peter, please. So the next presentation will be remote. It's from Nicolas Allot, the CEO of Enquiring Minds. The title is Secure IoT Gateways, Highlighting the Industry Challenges and Identifying the Collaborative Innovation Needed to Address them. Nick.
Hi there. I hope you can hear me okay? Yes?
Yes.
Okay, cool. Right, great. So, good morning, everyone. First, I'll start with apologies. I had hoped to be there in person, but various travel constraints made that wasn't really possible. So hopefully what I'm going to present today is going to dovetail quite nicely with what both Peter and Michael have just presented on. And in some senses, the entirety of what I'm going to talk about can be seen as some sort of glue that may sit between some of those problems. So my name's Nicolas Allot. I'm from a company called Enquiring Minds, but fundamentally what I'm representing today is the sort of like the collective work of a number of organizations that have been running under the Many Secured project that sits under the Internet of Things Security Foundation. And there's approximately about sort of 15, 20 organizations affiliated that at the moment, some ISPs, some router vendors, and some technology providers. But fundamentally, the subject of my topic is secure IoT gateways, and what I'm going to try and do is sort of like dig into some of what the challenges are and the approaches that we're taking or starting to take to try and solve those. So, in summary, the Many Secured sort of project takes the somewhat contentious approach that device security is good, but gateway security is better, and that's for one very pragmatic reason. There's a lot of very poor quality IoT devices already out there. You can come up with all sorts of fantastic creative ideas for securing the endpoint, to some extent, even like the IDEVD and the certs are one excellent sort of like method for doing that. But you've got to be practical in terms of when that's going to hit the market, and also managing the transition phase between having some IoT devices of low endpoint security and some IoT devices high endpoint security. So we see addressing the gateway problem as important, and okay, it might be not better, but it's certainly complementary to the endpoint strategies, and eminently practical and potentially deployable in the near term without requiring a massive number of IoT devices to churn. And so pretty much everything I'm going to be talking about is from the specific context of that many secured tech stack. So that's a tech stack that's like an emerging standard, sort of like a lot of it in draft form. It's available on the website, and I'll give you the links towards the end of this project. But there's also an open source stack that's fully accessible, which also embodies a lot of these concepts. But I'm going to be talking about a lot of concepts. And I think the key points I'd like to make is, although everything I talk about is manifest in this stack, some of the ideas can be peeled off sort of like as individual packets. You don't need to swallow the whole beast. You can bite it off one chunk at a time if you believe the technology merits it. And yeah, why routers? I mean, it's a bit of an old bit of news now, but I mean, it's just and there's an infinity of these type of reports on the internet, but certainly one recent semantic analyst review estimated that about 75% of infected IoT devices are really caused either directly or indirectly by the router. So that fact alone is probably sufficient to generate the gateway focus. But additionally, it is a very, very attractive attack target. Any attack on the router generally, if it can be done from the outside, could be issued at a low cost, low economic cost, massively scalable. So it is a device that is empirically being attacked at the moment and will continue to be attacked because of the ease at which it can be done. But then there's the inverse reason, which is, okay, not only is it an attack target in its own right, it is a line of defense. The firewall and the other defensive methods and that the gateway has is your line of defense against the whole host of other devices sitting behind the gateway or router. And that's very much why we've taken the sort of the many secured branding. It's to sort of like try and capture this concept that this single thing is both responsible for the protection of all the devices that sit under its umbrella. But then there's a positive side of it as well. So there's the negative side, which is, okay, it's going to be attacked. But then there's a positive side. Well, and it's a bit like Peter was just saying. It is a potential, a line of defense that can be strengthened. It has visibility of a lot of the activity, and therefore has the ability to contain some of these threats. So challenges. I'm going to skip through a few. I'm trying to. There's quite a lot of these, but I'm trying to synthesize them into a few simple ones that's easy to capture. So the first one, it's a whole massive problem in and of its own right, and it's one of the problems that we started with. And I want to just quickly introduce it just to make sure people fully understand it. But one of the big problems we have with IoT security is, at the moment, it is virtually impossible to practically, usably, and securely secure the access between the browser and the IoT device when it's sat on the internal network. Fundamentally, go to 192.168.01 and have a think about how you secure that. You might think it's easy, but it's really a lot harder than it first appears. And why is this problematic? Well, it's problematic because almost every IoT device and almost every router recommends that this is the method via which you configure and bootstrap your device onto the network. So your initial user touch point with the user is fundamentally insecure because it's telling you to go over a website that has no certificate, and therefore anyone on that internal network can essentially sniff on all the traffic and the passwords, etc., etc. Now, there are alternatives like installing certificates in browsers, but there's a whole number of reasons why that's not a good idea. But the pragmatic alternative that people are taking is essentially issuing a new application via the App Store for every new flavor of devices or router that you want to configure. And there are all sorts of reasons why that might be a bad idea, both security-wise, but also possibly more impactful ecosystem-wise. So this is certainly a problem, and we'll come back to it in a minute, which I think is quite a fundamental foundational issue to do with the IoT and the gateway interaction. And yeah, okay, just as evidence, I've just picked up the BT router. You can almost pick up any one, just go to the, how do you configure it, and just look at what it tells you to do, and then ask yourself some questions. But the other question is, and I think the stuff that both Peter and Michael talked about are different dimensions of this, which is, if I want to use the router as a method of both detecting and protecting security, I've got one fundamental, really tricky question. What are you? What is that device at the end of the IP address? How are you behaving? To some extent, Peter touched on that, some of the unit stuff, and then what can I do about it? What's the containment and intervention? And to some extent, this challenge in the macro sense is what we're trying to address with the sort of like the many secured stack, but in quite an expansive way. And I'll just throw in a few other nuances. But these are really important because these are sort of, as far as we're concerned, really foundational challenges that really change the flavor of the practical solutions you can produce. One, heterogeneous networks. Not everything in IoT world is IP based. There's a few mainstreams one on the market, but that's certainly when you start going in industrial. The practical problem you've got if you want to contain security across the IoT ecosystem is you need support for quite complex network topologies, but also quite a wide variety of fundamentally different transports and network types. Second problem is, and I think the last two presentations, or certainly Peter's touched on this, is, okay, where you're getting your truth from. You want to say, and I'll come back to this later, you're taking a MUD statement. Where is that statement coming from, and how can you trust it? And sort of cut to the chase, the hard reality is, well, it's a pretty fluid thing. There is no single source of truth, and a practical solution needs to be able to reason under a reasonable degree of uncertainty. And to some extent, the final point sort of like echoes or reinforces that, certainly in the consumer space, but actually, from what I've seen, it's also true in the industrial space. The half-life of the device is probably longer than the half-life of the originating manufacturer on average. There's a lot of devices that you can buy, and a lot more importantly, a lot of devices that are out there where the manufacturer has ceased to trade, and therefore, any operation, any systems that require an operational flow that goes back to the manufacturer, is substantially problematic. But also, you need to, right from day one, start thinking about legacy support. How do you support devices for which the manufacturer is not providing any information because it doesn't want to do so? And how do you support devices for which the manufacturer is not providing any information because it isn't there anymore? I just pick up, this is a slide I think I originally did about 3 years ago, but this is just looking at the typical consumer rollout in terms of what a very common or garden IoT topology looks like. I'm not going to dig into detail because we can spend probably about 20 minutes on this slide alone, but the big takeaway for this is it's a lot more complicated than you might first think. There's a lot of routers and extenders. There could be multiple sort of like subnets on different routers. And the big one is what we put under this umbrella, protocol bridges. I mean, basically your standard Echo Plus, your Hue bridge, your Smart Thing, which are things you just go and buy in shops now, are protocol bridges. They're part of the IoT extended network. They're talking largely non-IP traffic, transcoding it onto the IP network. And sometimes that traffic goes to the cloud, and sometimes that traffic goes locally. And it's quite complicated. But also the other thing to draw attention to, this point one in the middle, the web user app, that accessing the device from the browser, any line going from there to a device on the internet is problematic because it's really hard to secure. Right, so before I go to the technical meat of it, I'm just going to do a slight sort of almost pseudo-philosophical distraction into, you know, what do we think the fundamental problem is here, and what part of the implicit assumption of how we're approaching it is, you know, what we need is a theory of types. So what do we mean by that? So let's just change perspective totally and think, you know, I'm going out to the woods and I'm living a subsistence existence and I need to survive. What am I going to eat? Well, one of the things you eat is mushrooms, is fungus, right? But as you walk in the woods, what you see is you just see and smell phenomenon. It's ephemeral. It's tastes. It's colors. It's smells. And what you're seeing in every, what you're perceiving is the evidence that an individual instance of a thing is presenting to you. But if that's all you know, it's very hard to survive, because your fundamental challenge here is working out which of these are going to kill you and which ones aren't going to kill you. Well, so what you need for that is you need a theory of types. You need to take these infinity of abstract instances and construct a taxonomy, a set of methods of classification, whereby you can start to delineate, you know, what's poisonous versus what's not poisonous. And, you know, that's a theory of types with the taxonomy, but then pragmatically, you know, this is what happens. You then need some sort of flowchart or some heuristic method to be able to then classify your individual instances based upon the phenomenon that you see into the type with some sort of, you know, ideally risk measure, because it's never perfect. You know, there's no ideal way of doing that. And there's an inverse problem as well. Okay, in a worst case scenario, you're poisoned. You almost need an inverse bit of logic that can work out from the poison symptoms, go back to see what the threat was. So it's a little sort of abstract little cul-de-sac to go in, but you know what we contend is all of those steps that you need when you're dealing with fungus, you basically need the same thing with dealing with IoT devices fundamentally, and really the linchpin of almost everything that I'm going to talk about from now on is this fundamental distinction between a device instance and a device type. So the device instance is physical, it's an observable event, you know, IP addresses, MAC addresses, etc. But it's ephemeral, it's there today, gone tomorrow. But a device type is conceptual, you know, it's not really described by individual events, but it's described by statistical descriptors and trends and sort of abstractions. But it's perpetual, the type lasts forever. But, you know, one of the fundamental challenges as you're trying to monitor and maintain the security of the device is being able to manage the map between instance and type in a practical way that recognizes that the information which you're being presented with can change over time, and sometimes it isn't necessarily fully trustworthy. So, all right, I'm going to jump right in. Okay, so what is it we've done? All right, so I'm going to jump right into technical detail, then I'll bubble back out and sort of like explain how it's built up. So what we've really done in Many Secured is identify the simplest sort of three standardized interoperable interfaces that we think we can define that allow us to build these architectures at scale. And these interfaces are the ones sort of like with the little orange sort of lines on, D3 events, D3 con, lifecycle and types. So let me explain how it goes together. So we start with a router or a gateway, and there's basically an outbound line and an inbound line. So the outbound line is what information does one or multiple routers have to send upstream to make the risk calibration exercise a tractable problem. Now, it obviously could be a full PCAP, yeah, but that's probably too much. And it's too heavy, and there's too much sort of actual data going over the wire. So it's pragmatically, it's going to be some subset of that needs to be sort of like moved northbound to a reasoning engine that can calibrate risk. And then the inverse of it is, so what can you do about it? So we just call that decon. So it's basically a finite set of remotely triggerable APIs that allow you to contain that threat. And in the simplest scenario, it's, create a VLAN subnet, it's disable the device, or the inverse is on board the device. And it obviously can be infinitely more complex than that. We're trying to keep it as simple as possible. And to some extent, I think, the stuff Peter was talking about, which is the UNet, is an implementation detail of what could happen inside the router to actually manifest and make those two APIs tractable. So it'd be an implementation detail of those interfaces. But there are, and I've got some slides later on to show that there are plenty of other ways of actually defining that. And the reason we've defined D3 events and D3Con the way we have is we've tried to keep it as agnostic as possible from the actual underlying implementation technology. So the control plane, yeah, you could implement with an eBPF filter, you could implement it with a firewall, you could implement some IP tables, you could actually implement it with a completely separate router. So we're trying to not lock down how it's done, but we're trying to sort of manifest and define sort of like the abstract interfaces it needs to support. But fundamentally, what's happening is happening at this MS policy level. So you can call that the brains. This is the thing that's reasoning on what it sees, constantly changing the sort of like the risk profile of the individual devices that it sees, and possibly recommending an intervention. So you've got these like three layers here, like cognitive reasoning engine. This is a very fancy just way of saying, well, it's a set of rules, right? It's a set of rules that is based upon what it's seeing in terms of the instance and what it knows in terms of a theory of types and any history it knows about the device. Based upon all that information, what can I infer? And then I think Michael touched on this in one of his questions. So, and what do you do about it, and how do you deal with the false positives? Well, to some extent, we don't have given answers to that problem, but we provide a framework in which it's possible to adapt many solutions. So there's basically an autonomous response layer. So your policy could be such that if you're inferring something has a risk level N, and you have a high degree of confidence you want to automatically intervene, then you can possibly decide to auto lock down. But if you don't have that confidence, then you can, via the interfaces that we've defined, also escalate those issues, those incidents, up to sort of like, classic human intervention, instant handling system. But on the right-hand side, this is where all of the real intelligence comes from. So basically, going back to what I said right at the very start, which is, a lot of what we're trying to do here is reason sensibly, intelligently about type. How do we do that? And basically, there's a whole load of stuff here we can use. We can have a formal description of types. We can have descriptions of firmware. We can have CVE, vulnerability databases, SBOM descriptors, device hierarchies, which are built up over types. And then also here, the MUD file, where that's influenced, that comes in there. And then we've got more sophisticated MUD files that I'll talk about in a minute. So all of this data is data which to some extent already exists. There are ecosystems out there. But actually, you can really see it. They're all basically, from a database perspective, a foreign key on one thing. And that thing is your firm understanding of what that type is. And to some extent, to really, really simplify it and break it down into something very, very pragmatic, right? MUD files are a great idea. They describe the restriction you can put on a device. Where's that data going to come from? So you can see this entire infrastructure as a method of implementing what we call fuzzy MUD, right? It's a method of softly inferring what that instance is, looking up the constraint that should apply, and then allowing you to act to the gateway to actually act on that information. So it's whereas the standard MUD sort of like definitions are relatively tightly coupled, we can basically loosely couple it now based upon an inferencing system. And then the second class of data, the metadata, the lifecycle management, the second blue box to the right, is distinct from the first because all of the information in the first box really relates to type. All the information in the second box relates to instance. The purchasing, the servicing, the provisioning, the retirements, the transfer of ownership, these are things that apply to the instance of a device, not the type. However, there's a lot of information, if you know what type your instance is, that you can look up in the box underneath that fundamentally helps with all of those exercises. because most of those exercises, onboarding, monitoring, etc., are essentially dynamic risk assessments. And what do you need to do that risk assessment? I need to look at what you are, I need to look at your history, what you have done, and I need to look at what you claim to be, and does that relate to other instances of a similar type? So that is abstract, how the whole thing fits together. So, to some extent, what it's doing is actually binding stuff that's already around. So, Peter's already talked about the MUD file. So the way that we use the MUD files in the many secured, or specifically the D3 statements, which are the foundation of it, is, well, we take the MUD description, we encapsulate it, and then what we actually do is we digitally sign it with provenance. And why do we do that? Because it's not necessarily the manufacturer's description of the use, it might be somebody else's description of the use. And by signing these statements and being able to assemble them, the reasoning engine, it allows us to be quite fluidly reason about that. So how do we know what type you are? So I see an instance, how do I know what type it is? Well, there's a number of ways that could be done. It could be done using IDEV IDs, as Michael suggested. MAF has just launched its spec. It's got a slightly different method of doing it, which is basically certificate-based. FIDO has also, another competing sort of spec, has also got a method of essentially tying an instance to a type. All certificate-based, all just, subtle nuanced deviations from each other in terms of the attributes embedding the certificate. And the reason that the many-skilled system is designed the way it is to be able to embrace all those different sources of truth into one view, but also pragmatically solve that same problem of what type are you using other methods. It could be, well, what did the user, you installed me, what did you think I was when I was there? Or it could be a purchase token. Or you could have some fancy AI algorithm that infers it from the behavior. The point is, every single one of those different methods has a different sort of trust chain, a different source of truth. But the statement's always the same. The statement is always a qualified statement. I think this instance of the device is this type with this level of certainty. But other stuff could be confolded in. I mean, I think the software bill of materials and CVE databases, okay, the interesting thing about them is, well, let's take CVEs. Go and register a CVE and type in the field that says, what device type are you? It's basically free-form text. If this project does nothing else but actually manages to provide a universal language or statement of types that allows those CVE statements to be able to unambiguously be resolved, I think that would be a massive bonus, because that allows the system, the gateway or the gateway management system, to be able to reason about the devices on its system based upon the current known disclosed vulnerabilities. But in a very flexible way that works, pragmatically, both through multiple competing future standards, but also legacy scenarios as well. So building blocks. So how do we actually do it? So everything, there's loads of stuff. I don't have time to go through the full details, but I'll just try and give you flavor. Everything is specified in sort of like draft form on the Many Secure website. Fundamentally, everything that we've done is built upon the W3C verifiable credentials model. And the reason we've done that is it's basically, it's a form of signature. It's a signed statement, but it's a signed statement whereby that doesn't have like a universal root anchor. So it's ideal for the problem that we're talking about, where there are potentially multiple sources of truth. And then over and above those verifiable credentials, and we have one statement for declaring firmwares and another for declaring MUD files, etc. What we try and do is make sure they interoperate by when they talk about types and when they talk about instances, we use an identity that will always and consistently resolve uniquely. And then we get to, and I think this was touched on in Peter's presentation, but just a break with Michael. So where does the information come from to some extent, and how do you trust it? Now, what we try to do is not lock down a fundamental method. We haven't tried to lock down. There is only one single source of truth. But what we have tried to do is create a set of standards where each atomic statement can be made in an interoperable way, so we define the schema, and that can be signed in an interoperable way, so we can establish the trust or the trust base that we want to infer to it. And then what we envision is there will be one or more what we call D3 aggregators emerge, which we will essentially assemble those. And the method of assembling it could be algorithmic, or it could be based on almost like open source principles, where a community of people come to a consensus view over which statements are more qualified than others. But the end result of the D3 aggregator is a view of the truth. So it's basically, it assembles all the D3 statements into a single view of the truth, where we know everything links together, we know everything sort of in a common schema, and then that could be presented to the gateway. And the gateway itself could possibly take its sources from multiple aggregators. So it's a very flexible method in terms of we're not locking down policy, we're not insisting there's only a single sort of source of truth for the originating data, but what we are trying to do is define the mechanical methods by which they can be built up. And in terms of, there are actually lots of use cases for these D3 statements, and I'm just giving a subset here. So the first and most obvious is the type assertion. So this is a statement that this physical device, this physical BOM of a machine exists, which can be further qualified. Well, there's this physical set of components which has got this firmware running on it at any moment in time. So for each case you publish a URI, it's got sort of a public key identifier or a GUID, and that defines your types. And then we can also then define the hierarchy of types, where we believe some types inherit properties from another. So it's very, very normal, like all devices that actually use the same firmware, of which there could be many physical instances, may share behaviors, may share sort of CV vulnerabilities, etc. So it's imperative we can represent that. So the next statement is recognize a type. So, and this is a linchpin. This is like, I as a human being, or I as a gateway, think that this MAC address relates to this specific type, this well-known type, which is a reference to UC1 above. And the design of the system is such that recognized events can be issued from many sources. It could come from the FIDO certificate, it could come from the IDEV ID, or it could come from the user just saying, I actually think it's one of these. And then use case 3, well, that's essentially the MUD statement, right? And actually, what have we done here? Well, we've absorbed the best of what's out there already, the MUD stuff, but we've just loosely coupled it using this soft freezing framework. And then I'll just talk about use case 4, so good time for questions as well. So use case 4 is like an advanced MUD. So what is a MUD? It's essentially, it's a form of a whitelist. It's a permissioned whitelist, an allow list. But actually, there's a lot of very, very interesting things you can do in terms of qualifying that behavior on a stochastic level. And you can use Bayesian statistics, you can use funky neural networks, you can qualify by velocity, you can qualify by volume, but actually these descriptors, I mean, we're not intending on standardizing, but we are intending on providing the language wrappers for people to express them, to be able to use. But that's where a lot of sort of like some of the creative differentiation. But by folding it into the same schema, then we allow the system to reason about it in a good way. And hopefully it will start to become apparent how this stuff can then be assembled to address some of the challenges that both Michael and Peter were talking about. So first question is, right, how long do I need to observe something to be able to write a rule? Well, I've got a bit bigger question. How many different devices declared of the same type do I need to observe before I can actually consistently infer the behavior? And hopefully you'll see that the individual building blocks that we've created actually give you everything that you need to be able to make that reasoning in a qualified way. And it gives you a method for different organizations for sharing that data very practically between each other, because we've literally locked down the schemas of how it's done. And we've also locked down the evidence base, which is cryptographic design, to be able to make those inferences. So yes, so just to leave some questions. So fundamentally, so where are we? So there's a website which is sort of like public and accessible. The specs are there in draft form, and there's a GitHub from which those are sort of like automatically generated, and any member of the Manychat community can actively contribute to that. But we've also got an open source gateway reference. It actually is, it's an OpenWRT package, something called EdgeSec. And EdgeSec, does implement most of the sort of technologies that you can actually see in the Upbound spec. So we're trying to iterate the spec against the implementation in quite tight iterations. And fundamentally, it is quite ambitious. It does sometimes feel like we're trying to boil the ocean, but hopefully, I think you can see some of the foundations of what we've been building are really addressing some of the really underlying challenges to do with the trustworthiness of the data and the integrating of the legacy information into the future looking specs. And it's relatively, we've still got a long way to go, but I mean, we've got quite a lot of stuff out there in the public domain already. And I think the final thing that I'll mention, partly because I'm interested in gathering more opinions on it, is we're in the midst of trying to kick off an initiative that we're currently calling the Virtual IoT Cyber Lab. And really, what is that? It's basically a method by which different organizations, whether they be research organizations or ISPs or security researchers, can practically collaborate on the data, the behavioral data, to be able to make, inferring these MUD files a practical and sort of like trusted intent. So that's pretty much all I wanted to say today. There are a lot more slides in here with a lot more detail for people that are interested. I'll make sure they're shared and available for other people to download. And obviously, I'm happy to take questions both online and offline. Thank you very much.
Thank you, Nicholas. It was a very good presentation. We have time for questions. Yep, Peter.
Peter Steinhäuser, Embed. Nicholas, those D3 aggregators, those, to me, from what I'm working on, is a very, very interesting part. So are there already aggregators available for research reasons you could work with? And what's the concept about the aggregators? Are those like community funded, provided, or is there a commercial background? Are both models possible? So
what we've tried to do is make sure the specifications are agnostic of the business model. Having been around for a while, I know the minute you do that, you're tying your assets to a post that may or may. The commercial thing is complicated. The current interim provisional stakeholder that has asserted an interest of being a D3 aggregator is the Internet of Things Security Foundation, because obviously that's where this technology was sort of like originally housed. But there is nothing in the specifications that insists on that. I mean, what I would imagine, because I think we've got basically, if we just look at everything I've just described, but only from the perspective of MUD files, right? We've got a massive bootstrap problem we need to deal with. How do we create enough MUD files for it to be useful and pragmatic? So I could see this happening in a phased way. It might start with some sort of like open source, crowdsourced community initiative that would need some sort of moderation or mediation that sits over the top just to sort of like make sure there's a level of quality there. And that could almost run as an open source project, albeit there maybe need to be a little bit of funding behind it, I don't know. But as things evolve, ideally what you would want is you would want the manufacturer to be the trusted source of that information. And then probably you need slightly more commercial aggregators then in place to then aggregate that. And the ideal solution would allow that transition between sort of like the crowdsourced to industry moderated manufacturer sourced information in a fluid way, rather than it being a big bang, because I think that's the classic network effect problem we've got with the MUD stuff. We need to be creative about it.
Okay, thank you very much, Nick.
Do we have any other questions for Nicholas? Okay, thank you. A round of applause for Nicholas, please.
All right, almost fell, but fortunately not. So a quick RIPE NCC update. At RIPE 48, we had the request from the RIPE NCC asking what's the interest of the working group for trainings. So the consensus was more or less the no trainings are needed. That's at least what we also have the meeting minutes. Now RIPE NCC made a survey asking about topics people would like to have trainings, and what we can see here, well, we have 27.6% of people seeming to have a certain need on that. So I would suggest on the mailing list, we just start a small thread asking what topics people would like to know about. I think this could be very interesting for the working group itself, and also could give a possible feedback to the NCC for trainings in case. Well, and now we reached the end of our session. Maybe some words from my side, also a short feedback about today's session. So we were again talking a lot about security, onboarding, trust factors, etc. So I think as a working group of the RIPE community, we in the future should also talk a little bit more about networking. And I hope that industry initiatives like Matter and Thread will bring us a little bit closer to that. So I encourage everybody to also participate on the mailing list. We've been quite quiet there. So I think we all have some work lying ahead. And with that, and if Sandesh does not want to add anything so far, but please.
Thank you, Peter. I don't have anything to add, but maybe if you are not subscribed to the IoT Working Group mailing list, please subscribe. Thank you.
Thank you, everybody, and have a great rest of the meeting. Thank you.
Good afternoon. I'm Ylva Singius. I'm one of the co-chairs together with Desiree, my co-chair, and Achilles, who's online. Unfortunately, couldn't be here physically, but it's good to have somebody also taking care of the online part of this meeting. This is the cooperation working group session. So if that's not what you're here for, the other room is, of course, at the other end, so you get lots of exercise. We have a very, very packed agenda today. We had so many good presentations offered to us that we really went through a lot of effort trying to squeeze them all in, which means we are being a bit unfair to the speakers, giving them rather short slots, but it is what it is. One thing I wanted to mention, that's before we get on with the actual program, is something we've been discussing in the group and in previous meetings, is this proposal for sender pays or fare charging on the network. That's been a lot of discussion. I wanted to inform you that there is a discussion paper coming out from the European Commission that's going to be for open comments. So that's something to watch out for, and we might look at maybe getting RIPE NCC to officially respond to it, as we might also want to respond to it as a community. But we will try to keep you up to date on that on the mailing list. So for the actual program, I'm going to hand over to Desiree, who's going to introduce the speakers. Desiree, floor is yours.
Yes, good afternoon, everyone, and thank you, Yul, for summing up the hard work of the working group co-chairs to squeeze in so many good presentations. And therefore, we also are happy to announce that we have a couple of speakers from the region, from Serbia, and our agenda has shifted a little bit. So now we will first hear from Dragana Ilic. She is a director of corporate affairs at Cetin, which is a local telecom operator. And then following after her, we'll have Lauren Crean from the OECD. She's a policy economist and analysis. Then we hope to hear from Lucien Castex from Nouvelle Université Sorbonne. He will, together with his colleague, I believe, yes, it's Julien Rossi and University 8. They will talk about the splinter nets. They have published a paper on this topic, and they will both be remote. And after that, we will hear from a researcher here in Belgrade from Share Foundation. A few words, where is this region, or rather Serbia, ranking in the Freedom of the Net report, to provide you some users aspects of how digital freedoms work in this region. And finally, we will hear from the Bastian and Chris Buckridge here, the update on the ITU Plenipot potentiary. So with that, I'll ask you to welcome our first speaker, who's Dragana Ilic from Cetin. She will give us an insight into the regulatory framework for telecom and ISP operators in Serbia. Dragana, the floor is yours.
Thank you very much, Desiree. Hello, everyone. Good afternoon. It's a real pleasure to speak and to be here among you today and to have a chance to present Serbian regulatory framework. As announced, I'm a corporate affairs director in Cetin in Serbia, and I will speak from my experience as public policy person and my legal background, and of course as representative of one telco company, which is not that traditional one telco company that you think of. Why not traditional one? So we are all facing last couple of decades, a kind of disruption in telecommunication sector and in digitalized digital economy sector. And standard, traditional telco operators had previously two major goals. One is to serve customer and to provide diverse services to end customers, and the other one was to plan, build, and operate big telecommunication network, and of course costly. So with the disruption that we are facing with new players, there are new obligations, there are exponential rates of data, and of course increasing demand of consumers, and therefore telco operator started with a new trend for dividing a portfolio of their business in one which is facing direct end customers, we call that ServCo or ComCo, and the other one which is providing network as a service to retail operators, but also to other operators as wholesale service. So here we are. Cetin is established in Serbia mid-2020, and not just providing network as a service to Yetel as here mobile operator, but also to other operators, ISPs, and other companies on Serbian market and in the region and within PPF telco group. So speaking about telco regulation, there is a scary table here, and it's not that scary at all. I have to say at the beginning that the most burden of telco regulation is on telco operators covering nation with nation coverage, and especially mobile telco operator, and other operators, meaning ISPs and others, do not have that many obligations. And of course, more obligations have telco operators facing, like retail telco operators, than wholesale telco operators. What is common is that they have one regulatory authority here in Serbia. This is RATEL, National Regulatory Authority, and that all obligations for all operators are set in the electronic communication law, and that law covers almost all that we as operators have to do. Other things that are covered by other laws, you can see there, are relevant to some of us. For instance, Cetin is just wholesale operator, so consumer protection law is not relevant for us. And for ISPs is not relevant environment protection law regarding EMF and doing impact studies, which is relevant just for mobile operators. So more or less, RATEL can reach to all of us, and RATEL is our regulatory authority. And I will now speak more about common obligations of all of us. So first thing to mention is that electronic communication law in Serbia is back from 2020. That means that it is in line with the regulation of European Union from 2002, partly 2008. So there are services which are recognized here on the left part are rather traditional telecommunication services, not new services are recognized under our law. When it comes to obligations, majority of services are under general authorization regime, meaning both me not having a licensed spectrum, both ISPs don't have specific regime which is just left for mobile telco operators having GSM, UMTS, and LTE spectrum. What are the obligations? I could briefly explain, just dividing them into three labels. One is toward RATEL, which means we have to notify that we want to have business under general authorization regime, and we have to report. We have standardized reports to RATEL on our customers, on our networks, on our services, and on our revenues and on our investments. And also we have other types of reporting from time to time when RATEL demands from us. Others is obligations that we have to obey in regards to our customers, which is cybersecurity, which is privacy, and which is end user protection as customers, as consumers. And I think that the third one I should mention especially is related to other operators that we are on the market with, because we have to have ability and willingness to provide access services to our infrastructure to other telco operators and other operators on the market. And this is especially important for operators with significant market power, as you can see on the next slide. So here are the data from RATEL quarterly report for second quarter of this year. RATEL does annual reports and quarterly reports summarizing what is the most important on the electronic communication market. So you can see from this report that Serbian market, when it comes to media content distribution, when it comes to fixed broadband internet access, and when it comes to mobile telco services, rather concentrated market. So you could see few big players and a lot of small players on the market. On the other hand, what could be interesting for you is access to fixed internet, which is more and more fiber. Still, well, unfortunately, still cable and XDSL are the major ones, but fiber optic is going further and is covering more and more customers, and customers because of that have a quarter by quarter better speed, and they have more and more speed, which is more than 100 megabits second. Well, RATEL performs market analysis at least once in 3 years here in Serbia, and they did it this year. And everything is more or less the same as it was. So we have like mobile and fixed termination as regulated market, and local access. Here in Serbia, Telekom Serbia is incumbent operator, so it is you can expect that Telekom Serbia is operator with significant market power. What is new is Bitstream access. It's just finished the market analysis, and that analysis pointed out that RATEL deemed that fiber optic access should be regulated as well. It was not in previous market analysis, so it was not regulated market so far. And the other thing which is important for us is that second player on the market, SBB, is to be deregulated according to their market analysis. So we are left with one operator with significant market power, which is Telekom Serbia. Others are not regulated so far. So according to this, you could see that well, Serbian market is a bit kind of a deregulating from time being. But since we had pandemics, and then we had elections in Serbia that took quite a lot of time. So I think that 8 months we haven't had like the new government, and now we just got it. We have a new Ministry of Telecommunication and Media, so we are expecting regulatory activity to be accelerated, especially when it comes to new electronic communications law. This law should be in line with the European Union Electronic Communications Code, and it will bring us with strong regulated net neutrality instead of soft regulated as it is now. we will have more focus on broadband and on coverage of all territory of Serbia with the broadband service, being that universal service or otherwise. And we will have new players which are not part of our traditional electronic communications market that could be using scarce resources as numbering is. And we will have preconditions for 5G auctions like small cells are. Speaking about 5G auctions, we have delayed 5G auctions 4 times of pandemics and then these elections. So we expect the auction to be until until the half of next year done. And players which are interested to participate and bid are usual suspects here in Serbia: Telekom Serbia, Yetel, and A1. And apart from them, SBB as the biggest player for fixed network and is interested as well to enter mobile telco market. One new thing that we have started recently is implementation of broadband cost reduction directive. And ministry just started with the first draft, and we expect that to develop during the next year and to be implemented during next few years, because this is really important for all of us for using infrastructure in the buildings and infrastructure of other operators, but other infrastructure holders like public sector is. And to have simplified permitting system, of course, which will allow us to build faster our networks, especially 5G network. And one important thing for all of us as well, as I mentioned, rural broadband is one of goals of the government. They have state subsidies for deploying rural broadband. First phase finished, and 400 settlements, 400 rural areas already got their operators that will build last mile network and will then use for 25 years mid-mile network built by government. The second call will be almost the same, with the difference that in the areas where nobody is interested to participate, government will build both mid-mile and last mile network, so the citizens of all areas of country could have decent fixed broadband. And the last one that I wanted to mention is Roam like at home. Since we are not part of European Union, so we have had to have something parallel in the pipeline. So we organized ourselves, and we already have Roam like at home with the Western Balkan 6 countries, and now we are doing further steps in order to decrease prices of roaming, data roaming, not all roaming, but data roaming between Western Balkan 6 countries and European Union countries. So I think that during the next year, our new Minister of Telecommunication would have rather a lot of things to do, and we will be really busy in shaping public policy and industry politics, and of course our business model to new environment, regulatory environment, and then to new business ecosystem that environment will create. So that's all from my side. Thank you very much.
As we don't have a rowing mic, please come to the mic if you have any questions for Dragana. If not, there's none online. Achilles, if you can tell us if we have any questions online as well.
Good afternoon from me. No, there are no questions online so far.
Well, hearing none, thank you once again, Dragana. And yes, so our next speaker is Lauren, and she'll be speaking about the policy advisor's role in routing security. So please.
Thank you so much. My name is Lauren Green, and thank you for having me here today. And also thank you, hello to our virtual participants. I remember you. There we go. So I work for the OECD, which for some of you in the room that may not know the OECD, I thought I'd just give you a brief little primer. It stands for the Organization for Economic Cooperation and Development. It's an international organization based in Paris, France, with 38 member countries, but we're going to expand that with some accession countries in the pipeline, spanning Europe, the Americas, and Asia. And what we do, we really look at a lot of broad policy topics, and I'm not going to go into all of them, but the ones I'll highlight today and the ones that I work on are connectivity issues under the digital economy. We also have colleagues that work on digital security, and putting those two communities together, our delegates asked us to have a look at securing communication networks. And through that kind of ask, we recently published 2 reports, one on the domain name system, the security of the domain name system, and the other, which I'll be presenting to you today, is on routing security and what's the role of policymakers in that. So when thinking about the report, we broke it down into 3 main questions. The first is, what is the scope and scale of routing incidents? And you have to remember that for our audience, policymakers may not be aware. And so what you talk about in the technical community and what policymakers talk about might not always be the same language. So this report was really aiming to provide an education, an informational resource for policymakers on this more technical topic. The second is examining what kind of security techniques have been proposed to address them, and also how effective are they, and using those two to inform thinking about policy. So what is the role of policymakers in securing the routing system? So we'll start with, when we were looking at this report first, we thought, okay, well, what happens when there's an incident in the routing system? What impacts do we feel? And those are kind of best illustrated with some anecdotal evidence. So I've just put 3 on the slide of pretty recent events. I'm sure a lot of you are familiar with them. One is on last year, October 2021's outage across Meta's application suite, which was an outage related to vulnerability or a misconfiguration in the routing system. And the other 2 relate to attackers leveraging BGP vulnerabilities to on specific cryptocurrency sites. But of course, just looking at the big, headline anecdotes doesn't give you the real story. So we also tried to look into what available measurement at a broader scale, what was the scope and scale of routing incidents. It was a pretty tough, it was a little bit challenging just because publicly available timescale data, there's not that much out there from a perspective that you can easily analyze. So I've put 2 here, and I will caveat that with the fact that we know that we'd like more, but on the left, or at least my left, you can see an annual time series trend, which is a bit short, but that's just from BGP Stream. On the right, we have another additional data source, which is the GRIP platform hosted at Georgia Tech, but actually aggregated by the Manners Observatory, and then also BGP Stream. So one thing I want to point out, especially that you can see on the monthly BGP events, is the discrepancy in the 2. So it's quite difficult to make any sort of assumptions about what the actual rate of routing incidents, how much it occurs globally. So moving to the second question in this report, we talked to not only our own delegates who are mostly from communication regulators, communication ministries, security regulators, but also we have stakeholders that participate in our working parties from from ITAC, which is the Internet Technical Advisory Committee. And we also undertook several informational interviews with technical experts. I don't know, some might be in the room. I know that some are here in this conference. But with that, from these discussions, we tried to highlight some of the security techniques that are being discussed by industry and the technical community, and to frame them in a way for policymakers to grasp the different areas that these techniques are trying to secure, what kind of vulnerabilities that they're trying to address. And they're just origin validation, path validation, and path plausibility are the three kind of bundles we have. I will say that we mention others. Of course, filtering is very important. We mention other industry efforts at an ad hoc basis. So moving to policy. Why do policymakers care about routing security? I think, first of all, as evidenced by the fact that we were asked to look at this, I think it's something that is coming more at the forefront of policymakers' minds, especially as the internet is becoming so important for the economy and society more writ large. So they're thinking about how to secure it, all aspects of that. I just highlighted a few here. The United States had a notice of inquiry that was published earlier this year on internet routing vulnerabilities. In Sweden, they undertook a supervisory review of 5 key stakeholders and assessed how they were mitigating and assessing and analyzing kind of some of BGP's vulnerabilities. And more dated perhaps now at 2019, ENISA's 7 steps to shore up the BGP. So with all of the analysis that was conducted in the earlier sections, we thought, okay, so what is the role of policymakers? What can they do? This is difficult for internet. Obviously, policymakers are only one stakeholder, and in the report, we duly recognize the role of network operators and also the technical community in developing and implementing these techniques. However, we thought there were some things that they could do, and 4 stand out here. The first is promoting measurement. As I noted in the graphs, time series data would be really great to better understand the incident of routing and all routing incidents, and also the effectiveness of some of the techniques put in place to manage them. Second, leading by example and promoting the deployment. That can be through their own IP addresses or asking ISPs that carry their traffic, trying to promote best practice there. The third is facilitating information sharing. This could be through established bodies like the regulator or CERTs, or just acknowledging what is already going on in multi-stakeholder and often international groups. And finally, defining a common framework with industry to improve routing security. And this can take kind of a range of different options, which I'll discuss on this slide. So I wanted to give you some practical examples of what we see OECD policymakers doing with regards to routing security. With the first recommendation on promoting measurement, we see some good practice in the United States with their NIST RPKI monitor, which is really helpful. It has some nice metrics there over time. By leading by example and promoting the deployment, a good example from the Netherlands, who have implemented a kind of comply or explain framework for implementing RPKI, especially for public IP addresses on government IT systems. Facilitating information sharing. Japan has some standards that try to set forth encouragement for network operators, especially after incidents, to come together, share information, and find causes and mitigating actions. And finally, the common framework with industry. So this, I've put a range there, and we really see this across the OECD. We see on the one hand, multi-stakeholder collaboration with government, with industry, with civil society. working on this topic. We also, that's an example from Brazil, for instance, voluntary guidance, those standards I mentioned in Japan, that's one example. And then we also see moving to more legal actions, but still in a kind of broad sense. Switzerland has some general security guidelines for ensuring security of communication networks. And then even in Finland, we see some specific secondary legislation that includes measures targeted at kind of like a basic level of BGP security. So the main takeaways of the report are, we know that routing vulnerabilities are there, and I think that's something that's been going on for many, many years. But we still see that incidents are happening and they affect the availability, integrity, and confidentiality of communications. So there's still something to think about. The second big takeaway is only what gets measured gets improved. And the OECD is really has a strong focus on evidence-based policymaking. And if there's no evidence, then you can't really make evidence-based policymaking. So the importance of that data and also the effectiveness of different security techniques is really integral. We also see several efforts going on to secure the routing system. But we wanted to highlight for policymakers that there's no silver bullet out there. There's nothing that they could say, all of network operators have to do X, Y, and Z, and then routing security will be finished. So we wanted to highlight some of the challenges in doing so, especially as routing security is a collective action and it requires many, many stakeholders to implement certain techniques. And finally, the report finds that there are several actions that governments can do to help support stakeholders to improve routing security overall. And with that, I leave the floor to questions if there are any. Thank you.
I'm Kevin Maynell from the Internet Society, but I'm also the project leader of the Manners Initiative, which was mentioned there. It's not really so much a question, but it's more just to highlight that, I mean, you're speaking about trying to get empirical evidence and measurements-based data that we are developing, or we have developed the Manners Observatory platform, which I guess you probably got the data from the report. And yeah, so that's something that we are aware there are some improvements that need to be made to that measurement data, but I mean, it is a good starting point, I think, and does provide a lot of evidence for the state of router security on the internet. So I would encourage people to go and look at that and use that data for this type of thing.
Yeah, thank you very much. And you're absolutely right. I think Manners, especially the work that you've done to support the GRIP platform, is really, really great. And as you see, we featured in the report, so thank you.
My name is Maarten Aartsen. I work for NLNet Labs, a nonprofit. I was wondering, I triggered on your remark about data-driven policymaking or evidence-based policymaking. And I was wondering if I saw that the report mentions open source in a number of occasions. Was any regard given to, or did you come across good sources of the data which would be relevant to policymakers when they're thinking about this topic, about the role of open source? Because you mentioned providing puzzle pieces to policymakers, and I'm somewhat concerned about, at this moment, about the visibility of the role of open source within this space. So maybe you have.
Yeah, well, I would say that we have thought about open source. You don't maybe get the full picture as I presented here, because we have a whole work stream that looks at securing communication networks, and one that is based more broadly, actually dealing with a lot of the topics more on communication network infrastructure, not specifically on routing security. And there we do talk about open source. We also talk about openness more generally, and some of the other trends that are impacting communication networks that we see. So we do talk about it, but not as highlighted in this report.
Thanks.
Jeff Houston, hi. One thing the OECD has done for many, many years is promote the idea of open markets and open and deregulated markets in order to achieve ends. And, you know, they've been a champion of this. I found that one of the few things in this report that was missing was actually an analysis of the economics of routing security. Because certainly from where I sit, it's an economic disaster. It's a complete failure in terms of market. No matter how hard a network operator works, they can't charge their customers more if they've spent all this money doing it. And on the application side, they're sitting there going, we're using TLS, we're using PKIs, we're doing this. We actually don't pay any premium to have our packets securely routed because we're doing everything we want and we're not going to pay an extra. So at what point, other than grand words from policymakers, do we align the market with the incentives of investors to actually achieve secure outcomes? Because without that, we're going to be having this conversation years onward, because without those natural incentives, very little gets done, but a lot of words get said and that's it. Have you given any thought to that?
Yes, unfortunately, we have thought about this. It is a problem. So I will say that we mention it a little bit in the report in the sense that it's a challenge, because we see that as a challenge with, exactly as you said, network operators would love to do this, but it costs time, it costs money, it costs resources. Sometimes it costs upgrading of hardware and software. That is not nominal. We pose that as a challenge, and you're right, it is a big one. And we also talk about it in, my colleagues with digital security more generally do talk about that as, how do we get consumers to value digital security enough to incentivize providers of anything, because they talk about it in a more general sense, to actually to put money in that and pay more for it. And that's not something that they've managed to do in industry. Maybe others have more. I haven't seen very many examples, but yeah, I totally agree with you, Jeff. Thank you also for your really a lot of help in the report. So
a pleasure. Thank you.
Do we have any online questions? Chris, you look like you want to say something.
Thanks, Julf. Hi, Lauren. I wanted to say, well, sorry, Chris Buckridge from RIPE NCC. I wanted to say thanks, Lauren, for coming to speak to this. As people there are probably aware, the RIPE NCC, along with the other RIRs and a number of other technical organizations, have been engaged with OECD for, well, more than a decade now, about 15 years, through this Internet Technical Advisory Committee. And this was a really good example of a paper where the OECD Secretariat, the researchers, came in with a draft and talked to the ITAC people especially, and we really did see a fair bit of back and forth and a fair bit of improvement to the paper. And that's really valuable. I think it makes the paper more valuable for OECD stakeholders, for policymakers, and it's great for the RIPE NCC and our technical colleagues to make sure that this is correct information that's going out to that audience. So yeah, I really just wanted to make sure people are aware of that. This is something the RIPE NCC is continuing to engage in. And yeah, look forward to working with you in the future.
Thanks, Chris. And yes, ITAC has been invaluable.
So I'm going to allow these two people behind me to ask their questions, and then we cut the queue and move on. Thank you.
Thanks, Julf. Jim Breed speaking as a private individual, freelance consultant, and general RIPE hanger-on for a long, long time. Jeff was talking before about the economic incentives for trying to get things done for securing the routing infrastructure. I'm going to say something very provocative here, and I'm probably going to get some objects flung at me in a moment, but does things like the EU NIS directive not have any kind of impact on that?
I would welcome your views on that. I think that's a discussion question that I would really love the views of this technical community, because one thing when we were writing the report, it's a delicate balance, because what we've seen is policymakers, first of all, shouldn't say, okay, you have to implement X, Y, and Z, because oftentimes we hear from industry and technical community that they don't really know what that actually entails. It might not be the right actions if it's too hardline, and there has to be some sort of balance in that.
The way some of the existing NISP provisions are actually enacted for things like DNS service and so on. There's nothing in there, as far as I know, anywhere where it tells the operators what software they should use or what procedures they should have. It's just, if you have an outage of longer than X, things will happen. So maybe something along those lines might be a potential framework, rather than getting into the nitty-gritty of whether you use manners or whether you use RPKI or whatever. It's more the point of this, if there's a routing outage, there's a stick that can be prodded if someone does that. That might be an incentive.
Yeah.
Well, I think a lot of people here would not like to welcome more regulation and more involvement of this in their day-to-day business.
You said it, not me.
Yeah.
But thank you very much. That's a really interesting comment.
Hi, David Hauser from the Otto von Guericke University in Magdeburg, Germany. Congratulations on excellent report on routing security, and thanks for having a section on design internet architecture in there, and thereby acknowledging the contribution of Scion to improve routing security, a network that now Swiss banks, for example, are using productively. So thank you.
Thank you. Yes.
Thank you. Thank you very much.
So the next presentation, we hope we have both of our panelists online, is Lucien Castex, and he's a researcher at the University Nouvelle-Sorbonne, and Julien Rossi, his colleague at the University 8 in Paris. They have just published a document on the splinternets, the EU scientific insight into splinternets, and they will dedicate 10 minutes speaking to us. So I hope you have some questions for them as well. Lucien, can you hear us? Julien? Okay, it seems like, oh, well, welcome.
Hi, can you hear me or not?
Really well, yes, and clear.
Perfect.
Is Julien also with you?
Should be connecting also from Paris.
Yes, I forgot to say that you are also the co-chair of the Internet Governance Research Center for the Society in Paris, in addition to being at the University of Nouvelle-Sorbonne. So would you like to start or wait for a couple of minutes?
Well, let's wait for one and start then.
Certainly. cacophony here, but yeah, it will. Lucienne, if you. Julien and Lucienne, we can see your slides and you can go ahead.
Perfect, perfect. Thank you. Thank you for giving us the opportunity to present the study. Let me just get to slide myself. Perfect. So I'll introduce the study quickly, and then I'll give the floor to Julien to dig in, and then we'll welcome questions if you have some. Would be really interesting to hear your thoughts about it. So basically, as you know, a number of recent events, technical or geopolitical, have increased concerns about a potential fragmentation of the internet. Fragmentation into a multitude of disconnected networks, also called splinter nets, hence the title of the study. And as a result, the panel for the future of science and technology, the STOA panel from the European Parliament, asked us to study the phenomenon from an R&D perspective, and basically to set out broad scenarios of policy approaches for the EU to respond to the issue. The work has been conducted in the framework of the Internet and Regulation Research Group of the Center for Internet and Society, which is in the CNRS in France, and which I'm co-chairing with Julien. Would like also to emphasize that the work obviously is a collective one and has been done by Clément Perarnaud from the School of Governance at the VUB, Francesca Musiani, Julien Rossi, and myself. So next slide, please. Oh, okay. It's been years, as you know, since access restrictions, customization for users have resulted in a number of divergences in the way that we actually access to the internet, to internet content, to services that are available to users. And the fear of the internet splintering is quite old. A number of research and policy papers explored the phenomenon already in the past, sometimes called as balkanization or splintering of the internet, either along geographical fault lines or commercial fault lines with silos and technology silos. As a consequence, the process can lead to the emergence of a landscape of distinct and autonomous internets and break the unicity of the internet. The aim of the study that we drafted is to actually explore the phenomenon in the context of the EU digital policy. As you know, a number of policy initiatives has been developed in the EU, from the Digital Services Act, the Digital Markets Act, the NIS2 directive, the eIDAS, or the currently discussed reform of geographical indications. The study also draws from several interviews of experts from different stakeholder groups, including private sector, society, Gulf, academia, and technical communities. And we also conducted a workshop with a number of experts to actually test the preliminary results with colleagues. Turning to the European Union legislative agenda, the idea is to actually draw a line and suggest that the phenomenon can be simultaneously a driver for positive opportunities, but also a catalyst for the worsening of the very same threat that we identified a splinternet. I'll give the floor to Julien if he can hear us to dig in a bit, and we welcome your questions afterward. Julien.
Thank you, Lucien, for this introduction. So I will give a quick and general overview of what we did, where we started in this review, and how we concluded. If we can go to the next slide, I think maybe I can do it myself. Yes, apparently I can. Early in the process, we were surprised to discover that internet fragmentation, although it has been a recurring theme in internet governance discussions for the many years already, was in a very early phase of agenda setting, let's say political agenda setting, meaning that the different experts and stakeholders we've interviewed did not have a common definition. So you can have a very strong definition that states that it is when there are absolutely no possibility to communicate between two nodes of the internet. But we have decided to take the approach that the internet was an infrastructure, but also a public sphere, which is enabled by the infrastructure. And as such, to the user, being cut off from some parts of the internet due to any reason, and not just reasons which are technical at the transport layer, could be perceived as a way of fragmenting this public sphere. We've identified, based on the literature and on discussions with different experts, different types of fragmentations which are outlined in the report, which can be have different impacts and which can be due to different types of factors, both technical, political, or commercial. We looked at the EU's public policy by outlining initially three different scenarios. One was maintaining the status quo, two was embracing fragmentation, three was consistently fighting fragmentation at all costs. Because we were providing advice and expertise to the European Parliament, that is to say to democratically elected officials, we focused our analysis on a legal analysis to see how these different scenarios would fit into the existing legal framework that the EU operates in. So that includes international trade law and, more importantly, fundamental rights. What we saw is that the first scenario was quite unlikely given the high number of policy initiatives in the sphere of the digital single market in the EU. Embracing fragmentation could lead to certain problems, especially it could be conceived as a restriction to the freedom of information, which is defined in the Universal Declaration of Human Rights, but also in the European Convention on Human Rights, as also the right to access information by any means and without regards to borders. Fighting fragmentation at all costs was also not possible given the case law of the European Court of Justice regarding, among other things, data localization and personal data transfers. And so this has led us to the conclusion that we need a framework where we can actually assess, based on well-known legal framework, what kind of policy initiatives can be compatible with the European legal order. And this is what has been called for a very long time now by the European Court of Human Rights, the test of the balance of interests, where we look at whether a restriction to a right, such as the right to freedom of information, which supports a united internet, and so whether any limitation to that right, thereby to the unity of the internet, is, as the court says, necessary in a democratic society. And this is where there is already a well-known legal methodology that we can apply, and which is what we conclude in our report, basically, which is to say that There are, of course, many different policy options that democratically elected decision makers can take, but given the legal construction of the EU, it has to be taken into account that any restriction to the unity of the internet has to be necessary in a democratic society, and in some cases it can be, as has been ruled by the European Court of Justice, for instance, with regards to rules limiting, restricting the free flow of personal data to countries that do not have adequate measures protecting the privacy and the rights of protection of personal data abroad. So I think maybe Lucien, you would like to add a few things, but I think that in a wrap, in a very short nutshell, I have presented the main conclusions of the report, but please feel free to complete. Thank you for your attention.
So I guess we are now open for questions. Anyone, both online and in the room, feel free. We have a question.
Sorry for hogging the mic again today, but I had a quick question for you. I think it's easy, but is your study actually available? Can you link to it somewhere? It seems like it's really interesting. Thank you.
Chat panel, yes, it will be also available too.
Thank you. We don't seem to have any more questions, so we thank you for this excellent presentation. Thanks for being able to participate.
Thank you very much, Lucien and Julien, and see you online. And we'll try and send a link to our members on the mailing list as well in the chat room. The next speaker is Mila Bajic. She's a researcher at Share Foundation, which is a non-for-profit organization in Serbia. They deal with issues such as freedom online and privacy of data and protection of users online, as well as their digital freedoms. So the topic is the report of the freedom of the net, and especially focusing on Serbia to give you a little bit of more taste how users here experience all these issues. Mila, welcome, and the floor is yours. You have about 10 minutes.
I'll try and keep it brief. Hello, everybody. My name is Mila Bajic. As Desiree mentioned, I'm coming from Share Foundation, which is a nonprofit organization that is based in Belgrade. So we work on some of the main points that we work on is kind of decentralizing the internet, keeping it free and open. And one of the biggest things that we actually did last year and again this year is doing the Freedom of the Net report. So last year was the first time that we did it, and it was actually the first report that is kind of based in the Western Balkans. So it was pretty much, it was a big deal. And we just concluded the second report that spanned from June 1st, 2021 to May 31st, 2022. So pretty much I think what would be interesting to mention is that, yeah, so this is it's a Freedom House produced report, the Freedom of the Net report, and it kind of goes through, it's a comprehensive report which ranks countries in order to see, determine the freedom of each individual country on the internet. So currently in Serbia, we're within the free category, but I think it is important to mention that we're kind of on the threshold of going from free to partly free, and there's a couple of reasons for this. So first of all, the report is structured in three main categories. So the first one is obstacles to access, which is kind of more of the the technical capabilities and infrastructural limitations, if they do exist, to connecting to the internet. The second one is limits on content online, which I think is pretty self-explanatory. And the third one is violations of user rights, which is actually the category where Serbia does lose the biggest amount of points. So I would kind of focus on going through this category and specifically talking about 3 indicators that kind of talk mostly about the ways in which internet service providers and telecommunication companies and also the government itself has access to users' data and the ways that is it protected or not. So I would start with saying that the good news is that individuals in Serbia are not required to register with the government for uses of online services, and that internet service providers are largely decentralized in the country still. So that's the good news. But unfortunately, the not so good news is that when it comes to state surveillance of internet activities, telecommunications companies are obliged to retain communications metadata. And there have been instances in which we have also logged that authorities have accessed this information through dubious legal means. So what we have been doing also in Share Foundation, even prior to doing the Freedom of the Net report, is that we have been kind of working with the Commissioner for Freedom of Information, and we have been exchanging the reports that the Commissioner has been doing on a yearly level and kind of trying to see how many, I'm sorry, I forgot the word, how many times there have been requests for access for information from telecommunications companies within the country. So an interesting thing that I would like to point out, that is when we were looking at Telenor's database, which is currently now Yetel, we saw that between March 2011 and 2012, police directly accessed more than 270,000 had more than 270,000 requests for access to Telenor, that is Yetel's database. And when it comes to data from 2020, for instance, which we kind of worked with in the first Freedom of the Net report, is that we saw that Telekom Serbia, which is the main operator that is kind of partially state-owned, received 1,417 official access requests from the authorities. This was followed by Yetel, which received 422, and A1 Serbia received 122 requests. What is interesting to point out is that when we were independently as Share Foundation doing kind of this research on the ways in which state authorities can access information from telecompanies, we saw that there is something that is called an application for independent access, which basically means that these organs do not need to file a request, an official request, in order to get this data, but they are kind of connected to the infrastructure of the telecommunication companies, which allows them to just directly access the data itself. And it's a worrying trend, because we've seen that as the years go by, these reports, these comprehensive reports that these companies should be submitting to the Commissioner, are kind of getting less and less, how can I say, comprehensive, but they're also, some of the telecommunication companies are just actually not even submitting them to the Commissioner. So we can't have complete information on what the amount of access to data that is being accessed by the commissioners. I'm sorry, I thought there was going to be a lot less people, so I wasn't prepared for a crowd this big. Anyways, I think I would just only mention that one of the good things, one of the saving graces, is that Serbia does have a law on personal data protection that is kind of aligned with the GDPR, which is pretty much word for word copied into the Serbian legislation. And it has been in effect since August 2019. And the other thing that I would mention is that the Commissioner for Information of Public Importance and Personal Data Protection is very open to cooperation. And we have had, as the non-government sector, we have had very good cooperation with him. And we were able to get information from him, but also get him on our side when we were trying to lobby and advocate for instance, in these specific cases for requests and access to citizens' metadata. But I think that there's still a long way to go because these questions are still not kind of in the public eye as much. So it's very hard to kind of explain to people why they should care about this. So tentatively, we are on in the category of free internet users, but I think it's a very slippery slope. And well, thankfully, now that we are doing the report, we can kind of see what's going to happen in the next couple of years. So I think I would stop there, and then if there are any questions, I'm here. Thank you.
Group always seems to deal with topics that have slippery slopes. So yeah, questions.
Rüdiger Volk, retired. One thing I wonder, it's great to hear that, say, GDPR is kind of mirrored. A thing that seems to be not really that clear in the EU is the control of access to metadata. Though the European Court has slapped, say, the German government or legislature a couple of times on attempts for grabbing metadata. And I wonder kind of how you would guess the metadata control here compares to what you would expect from essentially the EU legal system going up to the court.
Oh, that is a tough question. So unfortunately, I'm not a legal expert of any kind. So I can only give you my very, amateur point of view. But I do think that it's very tricky because in the countries I already mentioned, when we were doing our research, which we did in 2015, we saw that there were multiple avenues that the state would take to kind of access metadata, which didn't need any kind of court process or submitting any kind of request for access. So I think here it would be very hard to even try and kind of argue it because there's no precedent that allows us, because we've seen that actually not just metadata but also text messages of journalists have been leaked. They've been put into tabloids, and it's very clear where they're coming from, but nothing is being done to kind of curb it. So I think there's a long way to go. Thank you.
So the last two speakers are Bastian Gosling, who's here with us, and Chris, who'll tell us about the Uni ITU Planipot, and Chris, who would tell us about UN development. So get ready for the questions.
You can start queuing if you want. Hello, everyone. My name is Bastian Goslings. I joined the RIPE NCC Public Policy and Internet Governance team in April. This is my first RIPE meeting as a RIPE colleague. So thanks for having me. I'm very happy and proud to be on stage. And also I feel very honored, to have been given the opportunity to summarize once in a 4-year event that lasts 3 weeks and a couple of thousand government officials come together to negotiate. I will attempt to do so in 15 minutes, and I think we're nicely on schedule, so that should also give us some time for a Q&A. Just to start off, why the ITU? I just want to, this has been shared before in other presentations, but why exactly do we engage with the ITU and how do we do so? Well, the ITU is the International Telecommunications Union. That's a United Nations agency involved in telecommunications, which obviously by now also includes the digital sphere and the internet. And that also then touches upon the business, that we as an RIR are into. So our objectives, basically speaking, is on the one hand, to complement the ITU on the work it's doing, but also to keep an eye on the fact, that it indeed continues to stay within its mandate and cooperates with organizations like the RIPE NCC, but does not get involved in the actual work that we are doing or to try to take it over. The ITU, as far as we are concerned, is not the place to develop internet standards, for instance. Combined with that, we're very proud, to convey the message and to share with governments, how we develop policy within the community, the multi-stakeholder approach, and combined with that, supporting the open internet model. And obviously, we share, the technical details of exactly what we do, what is within our remit, the technical functionalities that the RIR system performs on a global scale. And we do so because the ITU mainly consists of member states by sharing technical expertise with member states. In order to participate within the ITU, you need to be some form of a member. Well, the RIPE NCC is not a member state, but we do have the opportunity to be a sector member. We are a sector member of both the ITU-T and ITU-D. The ITU-T is involved in standardization and ITU-D involved in development. And the way that we contribute to discussions is to be part of regional coordination groups. There are a number of study groups. I mentioned a couple of examples, but there are more popping up that we can contribute to. A number of major conferences since COVID. Last year we had like a few big ones, one of which obviously I will be talking about. And there are some informal expert groups, and where applicable, we can also contribute to those. Now, the Plenipotentiary 22 meeting. Just, to frame what this type of meeting is about. As I referred to briefly in the introduction, this is held every 4 years. It's the main decision body, the Plenipotentiary Conference of the ITU. It determines its overall directions, 4-year strategic and financial plans. And combined with that, during this meeting, the senior management positions are filled. People are elected, amongst others, the Secretary General and Deputy Secretary General. Thousands of government officials come together from 193 member states, if I'm not mistaken, including high officials like ministers, who especially in the beginning of the conference participate as part of all the ceremonies that take place. Many things are discussed there, amongst others, a huge pile of resolutions, a number of which we tend to call the so-called internet resolutions, and those are the ones I'll be focusing a bit more on later. That's where we participated in. The negotiations that take place at a conference like this are actually, between regions. It's most effectively, to try and see if you, based on regions, can come with common positions and, bring those to the conference in order to talk to other regions, but also member states on an individual basis, can submit proposals. Well, for the 2022 edition that just took place, that was from 26th of September up until the 14th of October. It took place in Bucharest, in the famous big parliament building by now. And basically, it's not set in stone, but the structure is more or less as follows. The first week, the elections take place. At the end of the week, there's a lot of lobbying, of course, leading up to the elections themselves. And as part of that, there's a lot of networking involved. A lot of countries that are providing candidates organize receptions and coffee moments and lunch. So I'm guessing that the colleagues who have been there during the first week must have had a great time. I was not there during the first week. During the second week, and in this case, in practical, it started a bit earlier, but just to give it some form of a division. During the second week, so-called ad hoc groups are formed, and those are the groups where the actual negotiations take place with regard to the resolutions. And the idea is that consensus is reached within a certain time frame, and texts are finalized, which then can be agreed in the plenary meeting. So the idea is then in the last week to actually finalize all the ad hoc work, get agreement on texts, and then they can be rubber stamped and agreed upon, and we can celebrate, you know, that we all are finished and done, have agreed upon, and can look forward to another meeting in 4 years' time. In general terms, if there are disagreements and no consensus is reached, and we can all agree that we don't reach consensus, that means no change to text. So leading up towards the conference itself, because you can imagine every 4 years and you have like a 3-week peak of all these sessions, there's a lot of preparational work leading up to those. There are the regional deliberations. I already referred to the fact, you know, that a lot of work is done within regions. And we as a RIPE NCC participated, at least I and Suzanne participated in the European region deliberations. To work on European common proposals. Shafiq and others, you know, worked with the Arab states when they determined their regional propositions. But the same happens in South America, North America, Asia, Africa, former Soviet republics, the Russian-speaking countries. They all, you know, come up with their proposals. These proposals have to be submitted before the conference. There's a deadline for that. And that gives you also then the opportunity to prepare for the negotiations, because you can see what the other positions are. And then you can see, hey, well, what are the gaps between our position and the colleague's position, and determine, okay, how can we define a negotiation strategy, and what is our bargaining position, and what are we prepared maybe to give up in order to gain something something else. In our case, the RIPE NCC was not the only internet organization present. The other RIRs also had like colleagues there, ICANN as well, ISOC, and these are also like entities that we prepared, you know, for leading up to the conference to share knowledge, experiences, you know, expectations. A number of them, the other RIRs, especially of course working within other regions, could give us intel with regard to what was happening there, and we could do the same for the European region, for instance. Well, as I referred to at the conference itself, we have the ad hoc groups based on themes. I referred to the internet related resolutions. Those were the focus point for us, because, you know, topics that are discussed in those potentially affect or directly affect the RIPE NCC's, the RIR system, the RIPE NCC's business. And just to be clear, we are a sector member. I refer to that. So that in this case means that we cannot negotiate ourselves. So we can be there and provide technical input, and in informal meetings, you know, we can have a voice, we can say something, but we cannot vote, and we cannot officially participate in the negotiating of the text. You have all those regional positions, maybe from other countries as well, single member states, and everything is put together in huge documents, so you can see all the different proposals. And then actually what is done within those ad hoc groups, through all those different proposals, step by step, you know, people get the opportunity to present their position, others get the opportunity to argue against those or to support it. Very time consuming and like wordsmithing, and like it's extremely like so different as opposed to what you normally are used to. But the idea is then, you know, that text that we cannot agree upon, and we at least agree upon the fact, you know, that the disagreement, you get rid of that. Existing text remains, and it's also very nice, you know, to see if people do agree upon new developments which deserve new text, and then we can say, okay, let's add this to those resolutions. Obviously, I think it's probably a no-brainer, but besides the groups, you know, where these texts are negotiated, and these sessions are also like online available for people to follow and to participate in. There is many informal one-on-one sessions, you know, in the corridors, in the hallways, but also sometimes organized. If agreement cannot be reached between certain parties within an ad hoc group, the chair of the ad hoc group will say, well, can the regional coordinators, you know, come together, just the 2 of them or the 3 of them, and these points, you know, can they talk about that in the hope that separately they can reach consensus and then bring it back to the group again. We had a number of WhatsApp groups, you know, both with government officials on them, but also RIR colleagues, depending on topics. A lot of traffic there, of course, also during sessions to keep each other aware and of what's happening. So the internet-related resolutions. I just took out, because there are more, I just took the most relevant and obvious ones to us. I put in the slide back, and that's available for download. Obviously, not only my notes are in there, but also there's more detail on the specific resolutions and specific text, and also links. You know, if you really want to see the actual resolutions and the final acts, everything that was agreed upon, you can find it there. I don't have the time to go into that now. But the resolutions, you know, that we were more closely following were internet-related, internet protocol-based networks. You know, those that had relations to either the domain name system to a lesser extent, but for us especially, you know, the IP addressing distribution system. Those are particularly relevant to us. Also, in terms of, you know, the ITRs discussions, are we going to organize a new World Conference on International Telecommunications, a new WCIT or not? Those were quite controversial. And then, of course, 180, you know, with regard to IPv6 and the transition, the so-called transition of IPv4 to IPv6, that was a very important one for us as well. With regard to a number of controversies, and I put them together because a number of them you will see are enclosed in more than one resolution. But I want to start off here, like in terms of what can we agree upon, not only the controversies. I think, you know, that one of the things that the ITU is focused on in these areas is, you know, to contribute, to see to it that eventually everyone can get an internet connection, which is framed as connecting the unconnected. Of course, if you see the amount of people that are on the internet or online, it's amazing what happened in those decades, but there's still billions of people who do not have the opportunity to use these type of services, and definitely, you know, not on a daily basis. So these are debates, you know, I think we can all agree upon. We want to take the next step and see to it, you know, that more people get connected. And obviously, you know, the ITU is one of the oldest UN organizations as far as I know, and it is an important organization and it has a role to play. And in these terms, it's also, you know, very beneficial if they can cooperate with the other internet organizations. A lot of member states are not aware of a regional internet registry or not aware of what another organization might be able to do for them. So they by default go to the ITU, and then it's very helpful, of course, if the ITU can link member states, for instance, to a regional internet registry to see to it, you know, to help operators get IPv6 address space, for instance, right? People don't know who to talk to or how the policies work. So they definitely have a role to play there in cooperating with others. Helping member states, and also in terms of pointing them to best practices, information that is available and data, and also getting to see how can data be turned into useful information. But yeah, then what does that mean in practical terms? What is the ITU then going to do? How does that translate itself into a mandate and a fitting role within the entire ecosystem? And then it becomes controversial in terms of what is the limit or what is the mandate of an organization like the ITU, and what should the resolutions call for? One of the things, you know, that, and it's in 102 resolution, 101, 180 as well, I think also 133, like the position of internet organizations like RIRs. In the existing text, we will refer to in a footnote. Certain countries or regions argued for the fact, you know, that should be more prominent, be visible in the main text. Others obviously said, hey, well, these organizations should be removed entirely from the text. So that was quite a heated debate. Related to that, the reason to, as it stands in existing text, for the ITU to cooperate with these organizations is actually to increase the role of internet governance. So there are, of course, obviously countries that will say we don't want to increase the role of ITU in internet governance. The Council working on Internet, that was also one that's a working group within the ITU that determines, you know, what the direction is of studies and other work that is done in internet-related areas, only accessible to member states. There's an option for other stakeholders to provide input during a consultation. But at the end of the day, it's member states, and this preferably we would like to see more opened up, other sector members to participate, other stakeholders. That was quite a heated discussion as well. Well, I referred to the ITRs. A number of people think, well, we've been debating this back and forth for years. It's not going anywhere. Let's get rid of it. There's no necessity to organize a new WCIT. We don't need to change the ITRs. Others disagree. So what does that end up in summary for a number of resolutions? Resolution 1, actually, no, nothing really changed. No additional remit, at least for the ITU in IP-based networks. Same thing for 102, mostly no change. There was some additional language with regard to sustainable development, you know, the best practices, the role that the ITU could provide there in terms of information sharing, fostering cooperation, all these nice things, they ended up in there. So that's probably a good thing. There was a bit of a weird discussion with regard to 133, internationalized domain names. Countries were arguing for statements in text. Well, actually, they didn't even really know what the term meant or what the term universal acceptance stood for. So that made it kind of a blurry discussion. Anyway, that didn't lead to anything, though there was no consensus there either. That meant no change. So new text, and then explicitly also calling for ICANN-GAC activities to be reported more explicitly to ITU Council, which is fine. There's already an ITU liaison towards the ICANN-GAC. So I would think, you know, why start reporting or start reporting better? That makes sense. Resolution 180, no real change there either, but it's probably a good thing that we decided, or the consensus was to get rid of adopting of IPv6 and facilitating transition to IPv4, from IPv4 to IPv6. So the title of the resolution changed to promoting deployment of IPv6. Some new text, very benign. So all in all, I think quite good. Essentially, we were concerned, and that's like the attitude you have when you go in there. But yeah, I think at the end of the day, we can be happy. No fundamental changes. There's no guarantee, because also a number of countries and regions explicitly warned us this is going to come back. We don't agree. We want to renegotiate it during the next Plenipot. Okay, fine. We have something to look forward to. Maybe the idea that new IP or IPv6 plus related topics would be put on the agenda, would be discussed, not explicitly, but that doesn't mean they can pop up in study groups, which they to some extent are already doing. Think of Green IP in study group 5. And we made, or not we, I think that it's somewhat of a compromise with regard to the referral to the or internet organizations. They still in the footnote. So there is no change there. They didn't end up in the main text of the resolutions. And the same for the Council Working Group on Internet. It's still only accessible to member states, and other stakeholders can provide input during a consultation. On a high level, that was my overview. I hope it's useful. If there are any questions, I am available.
Thanks. I think we leave the questions still until Chris is done, and then questions can be
that makes perfect sense.
Yeah.
Is that okay with you, Chris?
Okay, go ahead, Chris.
Okay. So I'm just waiting for the slides to go. Oh, hang on, there we go. Great. Yeah, so thank you, Bastiaan. I'm going to keep this very short and encourage you to all have a look at the slides. I don't actually have many slides, but there are 3 slides that I could speak to for 5 minutes or speak to for half an hour very easily. The ITU, as Bastiaan mentioned, is a UN agency, even though it actually predates the UN itself. But it's just one part of the UN that's actually involved in internet governance. And in some ways, a lot of the agreements, the compromises, the refusals to compromise that take place in ITU only really make sense in the context of this much larger UN discussion that's going on about internet governance. So I wanted to make a couple of points here, because I think the real key takeaway that I want you to have is that now is not the moment to take our eye off the UN. This is actually a really significant couple of years in terms of what UN decisions might be made about internet governance, or what the UN is more commonly now referring to as digital cooperation. Digital cooperation, it's a really high priority for the UN. That has become very clear in recent years. You'll see in the next slide some evidence of that. But what it's resulted in is a lot of different activities and initiatives taking place across different UN agencies, UN bodies, a lot of the time not always very well coordinated. and that's actually hampering particularly the ability of non-state stakeholders like ourselves to really effectively engage there, because the fallback position for a lot of UN participants and member states is that multilateral negotiation, which kind of shuts out non-state actors like technical community, like civil society. The real key event that I would say we're looking to, which takes place in 2025, is the 20-year review of the World Summit on the Information Society. Now, the reason I think this is so key, Bastiaan mentioned, well, let's say there are very few things as powerful in the UN setting as previously agreed language. I think Bastiaan made some reference to that in the ITU Plenipot setting, where if you can't agree, you go back to the language that you agreed last time. At the WSIS event in 2003-2005, they produced what's called the Tunis Agenda. And one of the agreements made there by the UN, by all of its member states, was support for a multi-stakeholder approach to internet governance. And in so much of the participation and the engagement that we've had with governments, with the UN, we look back to that Tunis Agenda. We say, you agreed in the Tunis Agenda that multi-stakeholder is the way to do internet governance. We're going to hold you to that. Now, a 20-year review of that World Summit on the Information Society actually allows for opening up that commitment, reevaluating that commitment. And I think there is a possibility that there will not be the solid commitment to a multi-stakeholder approach that we saw previously. So making sure that that survives this WSIS Plus 20 is really important. Across the UN, we're seeing geopolitical tensions play out, particularly in the case of Russia and its engagement with UN. We saw it in the ITU, we're seeing it in a number of other UN discussions. And that's definitely flavoring the negotiation and the discussion. But what we're also seeing is a lot of people pushing for opportunities for non-state actors to contribute. And I think the really key thing is we need to seize those opportunities, because we're not always going to get them. And yeah, we need to take that opportunity. Sorry, are you all on slide 2 now? I'm hoping my slides are changing here. I'm going to race through a little this next slide. I'm not going to explain everything here. What I was trying to do with this slide, and if I had a little more time to explain, is look at some of these new activities, developments, processes that are spinning up in the UN. We're seeing this come from the Office of the Secretary General. We're seeing it come from the General Assembly. So that IGF that we talk about a lot, the Internet Governance Forum, that's now just one cog in a much, much bigger machine. And the relationship between all of these different parts is often very unclear, particularly with most of them, as you can see here, having spun up in the last year or two. But we are moving towards that WSIS Plus 20. We're also moving towards something called a Global Digital Compact, which the UN Secretary General has asked the UN member states to agree. So last slide here, and I can let you all go. One thing I wanted to highlight is that there are opportunities for us to engage. And as I said, we need to seize those opportunities. One is relating to that Global Digital Compact, and the Office of the Tech Envoy, which is a UN office recently established, actually has an open consultation on that, seeking input from all stakeholders on what should be included there. So I'd encourage you to have a look at that, see if there's a possibility to provide some input. There is an ad hoc committee which is working to draft a UN cybercrime convention, which is going to be a pretty big deal if it actually makes it through. And there is an intersessional event happening on the 3rd and 4th of November, so next week. If you have a chance to follow that, one of the areas of discussion there is the role of the private sector in fighting cybercrime. So that's talking about expectations, obligations on private operators that may be agreed at the UN level here. And then the final thing is the IGF MAG working group on strategy. I'm a co-chair of that, so full disclosure, is currently developing an IGF action plan for WSIS Plus 20. So what that multi-stakeholder IGF community feels needs to be highlighted and prioritized in WSIS Plus 20. We have public calls every 2 weeks. The next one is next Thursday, so please join us. That link will take you to sign up to mailing list. And yeah, please, and also please reach out to me if you have any questions about that. That's my presentation. I don't know if we have time for questions, but I'll throw back to the chairs. Thank you.
We now have that sort of nasty balance of, do we take questions and get sort of told off afterwards for running over time or not? So, but I think we are okay with a few questions.
Jim Reid, internet hanger-on and frequent attender at ITU meetings, too many to mention. I don't have any questions for the comms team and what they've been doing. I just want to make a couple of quick comments. First of all, we should all be very, very grateful to Chris and his colleagues, especially Suzanne and Bastian, for the great work they've been doing, especially at Plenipot in the last couple of weeks there. It's a thankless job, and it's very important that the internet community is represented somehow at these meetings and their voice is heard, even if it has to be relayed through cooperative and friendly member states, as it happens to be at Plenipot. You do a great job at that, and I think it's underappreciated by a lot of people. So hats off to you all. The other quick point I would just wanted to make was in relation to Plenipot was the elections of the new officials for the new Secretary General. So the new Secretary General is Bogdan Doran Martin, who's been involved in the ITU for a long time. She was a former director of the development sector. She's a US citizen, and I think we're going to see a much more, shall we say, cooperative environment coming out of the ITU than we've maybe seen in the past now, because the previous regime seemed to be more interested in sort of trying to encroach on the territory of the internet, and I think that may well change. We'll need to wait and see, obviously, but I think the signs are encouraging.
Martin Winter, speaking for myself. You talked about the different resolutions, and they basically were about no changes done. So it seems to be about no changes impacting at least this community. I'm more curious, are there other discussions which went on, which didn't get through this time, but maybe at the risk that the next time they happen, which may have an impact to us?
I don't know if Bastian's there. I can jump in though. One thing I would say, there's been a bit of discussion about the fact that the OTT resolution in ITU was no change this time, and that's a good thing. But I think the interesting thing with that is that the OTT resolution is very much related to that idea which first came through, or not first came through, but came through in the WCIT conference in 2012 about a sender pays model. And that actually we've seen that kind of proposal now coming back, as Yulf mentioned at the beginning. So it's perhaps a case of energies being diverted away from let's try and do this in the ITU to, okay, let's try and do this in the European Commission and elsewhere around the world. So I think it's good that a lot of these issues were no change in the ITU. It doesn't necessarily mean the danger is gone or that the issue itself is not still live and being played out elsewhere.
Okay, thank you. And this the report or something, the resolutions, I was trying to get them online with all the remarks, but they seem to be, unless you are a sector member, so you cannot really get them. Is there any chance that the RIPE can make them accessible to the community?
I was just saying in the chat here, I think there is a full and final act published now, but it is restricted because it's only provisional. I assume that means there needs to be a final sign-off from some member states or other, but the final acts will be public at a certain point.
Thank you.
Right. I am closing the queue after Maria, so, but you three, go ahead. Farzan.
Hi, Farzan Abadi speaking. So I think that our community is grappling with something that is I call it ITU scare syndrome. And since I started my career, and that's a long time ago, I was young and I'm now in my late 30s, we were scared that the ITU is going to come up with some resolution that is going to one day affect us and affect the internet. And every time that there is a meeting coming up, we are hypothesizing about all these risks that we are going to lose the governance of the internet to this financially unstable bureau machine. And that has not happened. So I think that in the future, and I'm not saying that we shouldn't participate, but I think that in the future we need to have some criteria or yardstick of how we are like making changes and in IT, or if we should pay attention, and in what areas we should really pay attention, and what the effect of this participation really is, so that we can actually make an evidence-based decision whether we should pay attention to this institution, to this organization. Thank you.
If I can respond quickly to that, I do think there is a case that we need to manage expectations with the ITU and with the processes like this plenipotentiary. And I mean, the example I would give there is the success, the big success that happened 12 years ago and is still talked about, is getting the mention of the RIRs and ICANN into a footnote in these internet resolutions. Now what is that? That's nothing. I mean, it's a footnote. Would it change the work that any of us do if that footnote wasn't there? Probably not. But I think there is a need to, particularly for those who are, used to the mindset or the paradigm of developing RFCs or technical policy, diplomatic agreements like the resolutions agreed at the plenipotentiary are very different. It's just a different ball game, and I think we need to measure the impact, the significance quite differently than we do in looking at, say, a right policy document.
Rick Nelson, VIE. So I don't know if we can get the slides back up, but on slide 29 of Bastian's deck, on resolution 206, there was verbiage about fraudulent use of OTT applications that impact the revenue of operators. Was there any clarity as to what exactly that means?
Bastian, do you want to try to open that one?
Resolution 206, so 29.
Yeah, that's the OTT one, right? Just in case, that's not text that ended. That's not text that ended up in. That's not what you're saying, but like that, everyone that did not end up in in the resolution. Yeah, what does it mean? Like this basically comes from. What is it, Jim?
It's over the top. It means anything that runs over the top of the
telephone. Oh, sorry. My apologies. Yeah, over the top services.
Sorry, the question wasn't about OTT. I mean, obsolete telecom term. It was the words fraudulent and impact the business, right? That was what I was kind of getting at.
Yeah, what I was about to say, this basically boils down to a loss of revenues, right, for traditional telecommunication service, voice minutes and stuff like that. And that's what they then. So that's where it came from, and they call that fraudulent.
Right. So WhatsApp is fraudulent, or how does that? Okay. I mean.
Yeah, if you're a telco, you manage to convince your public authorities that this is fraudulent, then you can regulate it as such if you want to. But yeah.
Thanks.
Yeah. No, I understand. Yeah.
It was like, is this abuse or is this just application?
But thank you, for taking note of this and already going through the entire slide.
Thanks.
My take on it is, it's actually it is abuse. It's abuse of legislation. But
anyway, thank you very much, Maria Hall. I'm part of the Secretary Board, but also here talking as in my own capacity. I just want to say, as I've been to these ITU meetings. And this text massaging exercise that could end up in a success with the footnote. I mean, it's a lot of work. So now you're putting a lot of work on this, and I just want to say thank you so much. I think it's super important that not only RIPE NCC, I know that other persons from the technical community actually taking part and contributing to these discussions and this text massaging, which is apparently very important. So thank you very much for that. And I also want to thank the co-chairs for the cooperation working group for actually having these sessions to be able to have these discussions between the technical community and the players and the governments and so on. So keep up the good work. Thank you.
Thank you very much.
on that note, I consider we failed pretty badly. We went 15 minutes over time, but sort of, that's life. Thank you, everybody, and see you next time.
Thank you.
Ciao. Yes. Come here. Yeah, behind the, no, here, yeah, next to. Okay. Here.
What do you want me to tell me?
Yeah, you have a chair. Anyway, yeah, good.
So to take a picture of all of them.
Yes, and Chris, but he's not online.
I was like, here.
We should have a screen here as well.
Thank you.
Well,
Thank you.